So, hello everyone. Hi everyone. How are you all doing? I hope you all are doing great. So, hello my JEE warriors. How are you all? Do let me know first of all in the comment section that my audio and video is properly audible and visible to all of you or not. So, I can see many of the students have attended the class and eagerly waiting for the session. I was waiting for you too. So, let us start that with our backlog series, because I know many of the students are facing the difficulty that ma'am, this chapter are there in our backlog. So how to compensate them, how to cover the backlog. So Gigi ma'am, that is Gunjan Goyal ma'am, is here to help you all out. So hi everyone. Okay. So I can see over here. So do let me know in the chat section that ma'am is clearly audible and visible to all of you. Yes, beta. Everyone, I want that high-five emoji there in the chat section to see the motivation, to see the dedication of every student over here. Okay. Okay. So, hello everyone. Hi everyone. So, myself Gunjan Goyal, that is your chemistry educator, and today we gonna cover a very important chapter of your complete physical chemistry, that is mole concept, which your NCERT term as some basic concepts of chemistry. And I totally believe that this is for Arjuna students, and the Arjuna students are very new to the patch. They are very new to the concepts, so they need some detailed explanation from the scratch itself. So my method of teaching is the same only, beta. I will try my level best to cover the concept from the basic to the advanced level. And for this, I'll just tell you the lecture flow. So what will be the lecture flow? You just have to attend the lecture. Yes, ma'am. We will attend the lecture with proper dedication. Right, ma'am. After that, I want you to parallelly write down the notes of it as well. Okay, ma'am. We will do write down the notes as well. After that, what we have to do? After that, you have to solve the, during writing down your notes, you also have to solve the questions, because this is the main part. Along with me, you have to solve the question of all the things, all the concepts that we did so far. All right. You just have to answer them all and have to try them all. Okay, students. So if you are ready for this general flow, so then we can start our class with. Okay, so before we start our class, I want each and every one of you to just mark that thumbs up, to just put a like over the video, so as to see that how many of you are actually studying from the video. Are you ready for the backlash coverage of this chapter? Okay. Okay. So starting up with the first thing, that what will be the topics that we're gonna cover. But of this chapter, we will cover about the basic concept. We will do discuss about the atomic mass. What is the atomic mass? Okay. We will do cover the mole concept. We will do cover the stoichiometry and limiting reagent concept. We will do discuss about the stoichiometry and the limiting reagent concept. Okay, we will cover the laws as well of chemical combination. Laws of chemical combination. Laws of chemical combination. So these all are the things that we're gonna discuss in this chapter. Okay, so I can see over here that many of the students have attended our class, and I want you all to just mark on your attendance by hitting the like button. Okay, sure. Okay, beta. So starting on with the first thing of the chapter, that what is chemistry and why we are studying about the main portion of chemistry, how the importance of chemistry there in our daily life is. First of all, we can say that chemistry is basically the main base of our agricultural needs, right, beta? For agricultural needs, we can say that many of the pesticides, insecticides, right, many of the chemicals are used there to increase the yield of the crops, right, beta? So these are the basic use of chemicals that are present there in our environment, right? Then moving on to Then moving on to preservatives of it. Then moving on to preservatives, that chemicals are used as the preservatives as well, right beta? For the preservative, we can say that, can you tell me the name of the preservative that you know? Any one, right? Any one preservative that you know that is used to preserve the foods. Yes beta, yes. I can see. Yes beta, this is your one shot that will cover all the concept. Okay beta. Yes. So preservative, for say sodium benzoate is the preservative that we use to preserve the food articles, right? Yes. Then moving on to the another thing, that in health and medicine, the chemicals are used in health and medicines as well. Yes, ma'am. We can say the life-saving drugs. This is the antipyretics. We can say to lower the body temperature. High fever, we can use antipyretics, analgesics to relieve the pain. So these all are the basic theory portion that will just tell you that how the chemicals are important for our life, because once we know the importance of chemical, then only we can come across the different application of it. Okay, so this is antimicrobial to cure the infection, anti-malarials are also there. So all these chemical are useful as a drug for our daily life. Okay, then moving on to another thing, that is antibiotics. You all know, you all are the very well aware about the concept of antibiotics, that how antibiotics such as penicillin, okay, amoxicillin, streptomycin, and numerous number of broad spectrum antibiotics such as tetracycline, chloroamphenicol used for the treatment of various number of diseases. Anti-fertility drugs are also different type of drugs that is used for curing the fertility problems, right beta? Okay, yes, yes beta. Okay, so moving on to life-saving drugs like cisplatin, Taxol to treat cancer patients. Then AZT, this is azithromycin. Okay, so this is used to help the AIDS victim so as to cure the problem of AIDS. So these are different life-saving drugs that we use to cure the patient that are suffering from several type of diseases in their day-to-day life. Moving on to comfort and pleasures, different type of articles we use for, say, if we do discuss about the building materials, synthetic fibers, articles of domestic use. So these all are the purpose of chemicals in our daily life. Okay, moving on to comfort and pleasure luxury, we can say that different type of chemicals like fertilizers, acids, alkali salts, dyes, polymers, drugs, these all, soap, detergents, metals, alloys, different organic, inorganic chemicals, they are all the requirement purpose for our day-to-day life. All right, moving on to new materials. So we can say that different type of materials like conducting polymers, optical fibers, microalloys, all these things are there obtained from the chemicals only. In wars, we can say that different type of like TNT, we can say explosive, trinitrotoluene, that is used in the war purpose, nitroglycerin, poisonous gases such as mustard gas, if any one of you know about it. So these all are the different we can say chemicals that are used there in the wars as well. Then moving on to for transportation, we are having different fuels, right, like gasolines, natural gases, lubricants. We are having different things that chemical comprises of that are used as the daily life thing. Okay, that is all about the application and that is not that much important, we can say. Now we will start with the main part of chemistry. So now if I ask you about matter, in the chemistry portion we do discuss about matter beta. Now what do you mean by matter? Ma'am, we have learnt matter in our class 9th, right? You must have studied about matter. So if I do ask you all, before I start the point with, if I ask you all, what do you mean by matter? What do you mean by matter? I want my student to answer the question there in the chat section because I am reading it all. Welcome Anubhav, welcome beta, welcome everyone. Welcome for attending the class first of all, and do let me know in the comment section that what do you mean by matter? What do you mean by matter? According to you, what is the basic definition of matter that you have studied in your class, lower classes like class 9th only, right? So first of all, matter. We'll start up with matter. Matter is anything that occupy space, that have mass, that have volume, that have density, right? So these properties make any substance to be categorized under the category of matter or not, right? If I, yes beta, very good. Anu Gusen, very good beta. Yes, exactly. Ma'am, matter is Abhinay, correct. Anything that has mass and occupies space, yes beta. Mane creatives, yes, correct only. So this is the thing that you all are familiar with, right beta? So matter is anything that occupies space having mass. If I do ask you about air, whether air is considered under the category of matter or not, whether air is considered under the category of matter or not, do let me know in the comment section that air is matter or not. Air is matter or not. Air is matter or not. Beta, water is matter or not? Yes, so air is considered under matter because it occupies the space. Right now, there in the studio itself, I can see that all the space over here is occupied by matter only. That is air, right? Water is a matter, right? Emotions, do we consider emotion? Right now, I am feeling, we can say, a very joyous emotion. So, whether the emotions are considered the category of matter or not. So, emotions, we can say, emotions are considered under the category of matter or not. So I know majority people will say no ma'am, emotions are not at all matter, right? Yes, so you are very much familiar with the term matter, or what things are classified as matter and what to be not, right? All right, very good beta. This is how I need my student to answer the question correctly. Okay, and for all those who are new to our session, just hit the like button to mark on your attendance that yes ma'am, we are attending the session with the proper dedication, because before that we just destroy this chapter, right? And this chapter is very much necessary for all the students that are attending our class, right? So this is very precious for all of you. So just keep the notes there with you, write it all down, and with the proper dedication attend the lecture till end. Okay, along with me. Okay, so this all are the category of the matter, we can say. Now anything that occupies space, let us say this is a matter, right beta? So the smallest particle of the matter is atom. The smallest part of matter, the smallest indivisible part of matter is what we name as atom. Okay, so this is the classification of matter and atom. I guess the thing is clear to you all. So first of all, if we do discuss about matter, so anything that occupies space having mass, volume and termed as matter. Yes ma'am, this is clear to all of us. All right, then moving on to atoms. Atoms are what? The basic unit of matter. That atoms will combine themselves and will create the matter that we can see over here. The pen is matter, the specs is matter, ma'am is matter, but there is some basic part, that is atom. That simple. Now one more thing is there, that is molecule. One more thing is there, that is molecule. Now what is molecule? These terms are very simple and you all have to be clear with the terms. So this is molecule is the group of atom, we can say, because atom is the thing that is difficult for the independent existence. So atoms combine there with each other to create the molecule. So atom combine with each other to form molecule. To form molecule. Is that clear to you all better? To form molecule. Yes ma'am, this thing is very much clear to all of us, right? Then moving on to, there are overall 118 type of atoms, okay beta, that are making up the whole universe. Overall, the number is 118 that we will discuss, and the subsequent parts as well, I'll explain you the elements of all the elements as well. All right, moving on to another term that we usually use there in chemistry, that is chemical reaction. These are basic terms. What is chemical reaction? We can say in a reaction there are reactants that will react together with each other and will convert to product or products, depending on whether we are having the single product or we are having multiple products. So this is the basic flow of a chemical reaction, where some species are reacting there with each other, single or multiple, and will convert there to a product. Okay, so there is the change in the composition, change in the properties of a substance. That means it is undergoing chemical reaction beta. I guess the thing is clear to you all. Do let me know in the comment section with a thumbs up, and I can see some students didn't hit the like button for the attendance purpose. I want all the students that are there dedicatedly listening to me, just hit the like button to mark your attendance that yes ma'am, we are attending the lecture with proper dedication. Okay, moving on to beta. This is all about atom and molecules. Now moving on to the basic thing, that is chemistry, because this is the first chapter of your chemistry and you all have to know that what is the mean of chemistry, the basic science of branch of science that is dealing with the, for a chemistry teacher or chemistry student, we can say that, let us say this is the substance that are present over here, right? Now what is the chemical composition, what is the chemical property, what is the structure, what will be the changes that will undergo if we are keeping the structure, if we are keeping this matter in different conditions. So this is how we can say, the chemistry person will say that this is the substance, how the chemical composition of it is, how many changes it will occur if we increase the temperature, if we decrease the temperature under different conditions. So these are the changes that it will do. Study of all these things are coming under the category of chemistry. That is the branch of science itself. So we can say that chemistry is the science of atoms and molecules. That is it. Okay, that is it. Is that clear to you all, beta? Thumbs up I need. Yeah. Okay. So this is all about chemistry, the basic definition that you all have to be familiar with. Moving on to matter. Yes, we already did discuss. Now the classification of matter. Matter is classified under two broad categories based on their physical and chemical classification. If I do discuss about the physical classification, physically we do classify the matter under three categories. Okay, depending on the physical state, whether it is in solid state, whether it is in liquid state, whether it is in gaseous state. So we do classify them as solid, liquid, gases on the basis of their physical state. That is physical classification. Yes, beta. All the things are clear to you all. As of now, we are just discussing very basic thing, and I don't want to give the ma'am duration. Duration will be 3 hours, beta. We will cover the chapter under 3 hours. Okay. No, so this portion of chemistry is very easy. So I don't want to give that much time to this portion because you are also familiar with the things. I am just brushing down your concepts. Okay. Yes. Okay. Fine, beta. Rakshat, Vishnu, everything clear, beta? Ame, everything clear? All right. Okay, beta. So then moving on to chemical classification. If we do talk about the chemical classification, we will categorize the matter under two categories, pure and mixture. For pure, we can say single composition. We can say that single composition. Particles are, we can say, of same nature. Let us say water. So we are having what? We are having what? Water, 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 water means no other particle except water is there in our component mixture, right? The pure substance are categorized as, we can say, that contain the particles of same nature. Okay. Mixture contain different particles along with it. For say we are having some different thing. For say we are having some different components along with it. So mixture is having some different composition. Okay, different particles enter in the container for say. Okay, moving on to the further category of pure substances, we are categorizing it under the two categories, elements and compounds. If we talk about the element, for say we are talking about the sodium element. So we do have the sodium particles only like this. This is Na, sodium, 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 sodium. So all of them are what? All of them are pure only because all of them contain the same particle, that is sodium. If we do talk about the compounds, beta, compounds are what? Compounds are when two or more elements combine there with each other. Two or more elements combine. Two or more elements combine together with each other. We do get what? We do get compounds. For say if I am taking an example of H2O only, so this is H2O molecule. 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 So it is coming under the category of pure substance only because all the particles are there of H2O only. So it is pure. We are not having any other particle, and we can say that 2 or more than 2 elements are combining. So we are having overall 3 atoms, 2 of hydrogen and 1 of oxygen. So this is compound. Compound are further subdivided on the basis of their nature, that whether they are coming under inorganic compound or organic compound. Majorly in organic compound, we do discuss about the carbon compounds. Not all carbon compounds are organic, but yes, majority organic compounds are carbon containing compounds only. So these are the further subcategories of compounds. There in the mixture, what I told you, that we are having different particles, right, that are further divided into homogeneous and heterogeneous mixture. Now what is homogeneous, ma'am? Homogeneous means that all the particles are uniformly distributed. Uniform composition. Uniform composition. If I'm taking the example of it, let us draw an example of, let us suppose we are having water, and over to water I'm adding salt, NaCl. So if I add salt in water, I'm getting a uniform mixture, right? That is having evenly distributed salt particles in water, right beta? But if I do talk about heterogeneous, the composition is not uniform. Let us take an example of sand in water, sand in water, sand in water, sand in water. Problem solving will be there, beta. Okay? Yes, problem solving will be there. Heterogeneous means we are having different components now, okay, that are not having uniform composition. Non-uniform composition. Non-uniform composition. Okay. Non-uniform composition means that we are having, let's say, sand in water. Sand in water. If I do take an example of sand in water, so sand in water is coming under the category of sand in water. So here we are having non-uniform composition. So this is heterogeneous mixture. Is this clear to you all or not? Okay. 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 Is this clear to you all, beta? Okay. Fine. Then moving on to a very important term. Now the question portion arises. That is atomicity. What is the meaning of atomicity? That how many number of atoms are there in a particular compound. If I do ask you about H2O, beta, how many atoms are there in H2O? Do let me know in the comment section. How many atoms are there in H2? How many atoms are there in N2? How many atoms are there in O3? How many atoms are there in H2SO4? How many atoms are there in H2SO4? How many atoms are there in C6H12O6? Yes, duration will be beta of 3 hours. Yes, basic chapter for JEE preparation. Yes, this is a prior chapter you all need to learn about. You all must be familiar about the terms that we will discuss there in the chapter. So this is a main chapter for all the students that are preparing for JEE. All right. Yes, beta. Very good. Very good. I need these type of students only there in my class who are answering me the questions. Okay, yes. So we can say that atoms that are present there in H2O are 3. So atomicity is 3. That means we can say it as triatomic. Okay, N2 contains 2 atoms, right? So atomicity is 2. That means it is diatomic. In O3 we are having 3 atoms. In O3 we are having 3 atoms. In O3 we are having 3 atoms. Very good. Yes. Anug. Yes. Very good. That are triatomic in nature. In H2SO4, how many atoms are there? 2 of hydrogen, 1 of sulfur and 4 means overall 7 atoms are there. Right, beta? And in C6H12O6, whose formula is this? C6H12O6. Basically, we do discuss about glucose with the formula C6H12O6, right, everyone? So, there are overall 24 atoms present in this unit. There can be other elements as well, like helium. Helium is single atom, having only single atom, that is monoatomic, beta. Monoatomic, diatomic. P4 having how many atoms? 4 atoms. Right? 4 atoms are there. So 4 atomicity is there. We can say tetraatomic. S8. How many atoms? 8 atoms. So 8 will be the atomicity. Octaatomic. So these are the terms that we do use. Beta, there will be numericals. Yes, I am teaching there in Arjuna JEE English and Arjuna NEET English. Okay? Yes. Very good, Anup. Very nice. Okay. Srishti. Thank you. Okay, beta. You might have studied from me. Okay. Thank you. Thank you. Okay. Okay, so we will discuss about the more calculative portion, but we just started the session, right, beta? So if we started the session, first of all, I'll teach you the concept, then we will go to the question practice portion. Okay, so you all will be getting the questions, you all will be able to solve the question, but before that, you first of all have to revise the concept, right? If directly I shift that to question, you all will be like, oh ma'am, what is going on? We are not capable of solving the question because we don't know the concept. So it is my responsibility to first of all teach you the concept. Then afterwards, we will simultaneously move on to the question portion. Okay? Okay? Yes. All right. Okay, beta. Okay. So then moving on to the next portion of the very important portion, that is, we do know about atom. We do know about atom. A rough structure of atom is like this. Furthermore, we will discuss about the structure in the next chapter, that is structure of atom. Right now, what the main thing that all of you need to know about atom is the subatomic particles. That atom, first of all, atom discussion was like that atom is the indivisible substance that furthermore cannot be destructive, furthermore cannot be subdivided. It is the main base. But afterwards, we get to know that atom contains the subatomic particles. Subatomic particles, right? Subatomic particles. There are numerous subatomic particles, electron, proton, neutron, antineutron, right? But afterwards, it was stated that the three fundamental particles, subatomic particles, are there, that are electron, proton, and neutron. So you all need to know the basic thing about all of them. First of all, their masses in kilograms. Masses are like proton and neutron share a common mass, 1.6 in 10 to the power minus 27, 1.6 in 10 to the power minus 27. Rough approximately they both are same only. Slight variation is there, but you all can say it to be the same only. Then moving on to electron mass. The electron mass is 9.1 into 10 raised to the power minus 31 kg. This is the thing that we usually draw out for the electron mass. Moving on to the AMU mass. In AMU, we can say this to be approximately 1 AMU, approximately 1 AMU, this to be as 0. Okay, approximately 0. Electron is very light in mass, so approximately we can set it as 0. Moving on to the charge portion. So proton carries a unit positive charge, +1 charge. Then moving on to neutron. Neutron is neutral, no charge at all, and electron contains -1 charge. So one negative charge is there with what we can say that -1 charge carries there by the electron portion. Okay, so these are the charge which are relative in nature. It is not the actual charges, they are relative charges. Means if we do compare proton with neutron, what is the charge ratio? We just say that the proton carries positive charge as compared to neutron. What is the charge of electron? We do share the electron carries a -1 charge there with the what? Neutron. Okay, moving on to the actual charges that they carry. Beta, the actual charges is by plus 1.6 in 10 to the power minus 19, and this contains minus 1.6 in 10 to the power minus 19. That is it. In columns, it is there. Neutron carries no charge. So you all have to learn this thing. Okay, that is it. Is that thing clear to you all? Do let me know there in the comment section. Is the lecture enough? Yes, beta. We will cover all the concept of the chapter. Okay. So do let me know in the comment section that whether the thing is clear to you all or not. Just put a thumbs up, and I can see that students are okay. Student not liking the like button. Just click the like button to mark the attendance, and then I get to know that how many students are there actively attending the lecture with the full dedication. Okay, clear, clear, clear. Just yes. I need that fire heart emojis there in the chat section so as to know that you guys are actually listening to me, attending the lecture with full motivation, with full dedication or not. Okay, beta. Now the atom is discussed there with the subatomic particle wala thing. Now we will discuss about the representation of any atom. So this is the, for say X element, I'm writing the symbol of element to be X. Then over here to the base portion is coming out Z. What is Z? Z is atomic number. Atomic number. Over to it we are having the mass number. Beta, this is mass number, not atomic mass. This is mass number. So these are the different things that we just represent for an element. Okay. So X is the symbol of the element. Whatever the element is, we do use different symbols. Z is the atomic number that comes under the element. Okay. Then we have A, that is the mass number that is present in the top of the element. Is it clear to you all? Now the different thing. This is how the symbol is written of all the elements. Atomic number represented by Z, that is equal to the number of proton. That is equal to the number of proton. That is also equal to the number of electron. But it is only be applicable if we are having the neutral species. I will explain you with an example. Don't worry, just listen the concept, then we will shift to the question portion as well. Okay, then moving on to mass number represented by A. When mass number is what? Mass number is number of proton plus number of neutron. So if I want to calculate, let us say, number of neutron, and how I will calculate it? We will just subtract the number of proton with the mass number, and I will get what? I will get the number of neutrons. So let us try with an example. Basic organic concept also, ma'am. Yes, we will cover all of it, but as of now, I am covering the chapter that is some basic concepts of chemistry. On your demand, if you ask me, if you want me to cover other chapters as well, do let us know in the comment section. We will definitely, whatever you demand from us, we will definitely bring all the things to you all, guys. All right. Okay, then moving on with an example. For example, if I do ask you about sodium is the element. All right, beta. Atomic number 11 and mass number is 23. Now I'm asking you that what is the proton, what is the electron, and what is the neutron number of this species. Okay, do let me know that in the comment section. I want to know that how many of you are answering the question correctly. Sodium, atomic number. If I just check out the symbol of the element, I can see over here that 11 is the atomic number and 23 is the mass number, right, beta? So, atomic number is 11. That means the number of proton, because I told you that atomic number is equal to proton and mass number is equal to proton plus neutron. Right, beta? These are the two formulas that I told you. And proton will be equal to electron only if the species is neutral. If it is not neutral, then it is not the same. Right? Very good. Anu, very good. Is attempting the answer very nicely. Next structure of atom, done. Vishnu, done. Next structure of atom, we will definitely bring that chapter for you. Okay, proton. But I want all of you to actively attend the session, okay, and click the like button as well. Okay, proton. So atomic number is 11. Proton will also be 11. Okay, since this is neutral, no charge is there on sodium. That means the electron count will also be 11 only. Then talking about the neutron, we can say the neutron over here is mass number minus proton. Mass number minus proton. Mass number minus proton. What is the mass number? 23. What is the proton number? Proton number 11. Proton number is just equal to the atomic number. So we can say that mass number minus atomic number, because proton and atomic number is same only, will be equal to the number of neutrons. So we can say over here 23 minus 11, that is 12, will be the number of neutrons in this case. This is very important. You all have to find out that what are the count of the electron, proton, neutron in the given species. For example, I'm taking another example, oxygen, that is having, let's say 18, 8 and 2 minus. For example, this is the case now. Do let me know beta in the comment section how many electron, how many proton and how many neutron are there in the species. Yes, now the new question arrives that you have to answer me that how many electron, how many proton and how many neutron are there in the species. O2 minus having atomic number 8, mass number to be 18. Do let me know in the comment section what is the number you are getting out of it, of electron, proton and neutron. Yes, try it by your own. Do let me know in the comment section. We'll see that how many of you are giving me the answer correctly. Okay, first of all, atomic number. This is the atomic number. This is the mass number. Atomic number will always be equal to proton, that is 8. Proton and electron are equal only when they are neutral in nature. But you can see minus 2 charge. And minus represent that any species gain the electron. When a species gain the electron, negative comes over it. So minus 2 means it gain 2 more electrons. That means overall the electron must be 2 more than the original one. That means overall 10 electrons are there. You just have to do the opposite thing. If the charge is negative, you have to add. If the charge is positive, you have to subtract. That is it. All right, beta. So this is the thing. Neutron, you just have to subtract the mass number minus atomic number. Neutron, for finding out the neutron, A minus Z means 18 minus 8. That means 10. If your answer is coming out to be the same, then that is very nice for all of you, that you are getting the answer to be correct nicely only, means you get the concept now. Okay. Okay, then moving on to another part. Is it clear to you all? Yes, beta. Is it clear? Is it clear to you all? Very nice. I can see Vipul, Vishnu, Raman Sutra. Very good, beta. Very good. Very nice. Okay. Okay. Shall we move? Okay, if I do ask you about any other species, let us say one more example. Magnesium. One more question. Magnesium, 12, 24, 2 positive. Again, electron, proton and neutron. If I do ask you about all these things of the species magnesium 2 positive, then do let me know in the comment section that what will be the answer that you all are getting. And don't forget to like the session as well, whosoever is attending our class. Okay. Yes, beta. Electron, proton and neutron. As I told you, the atomic number will be always equal to proton number, that is 12. Electron will come from the whether the species is neutral or not. If it is having a charge, we just have to do the opposite thing. Means proton and electron should be same. They are in a neutral atom. But if the atom contains any charge, that means over here plus 2 charge, you have to subtract 2, because 2 electrons are released by the atom. That is why it is getting a positive charge. So overall we can say that 10 electrons are there because it contains 2 positive charge. Now the number of neutrons come out to be A minus Z. A minus Z. A is 24 and Z is 12. That means overall we can say that 12 neutrons are there. Okay, beta. Okay, yes. Ma'am is always fine and attending the session. I guess you all are also fine. Okay. Okay. That is about the representation to calculate electron, proton and neutron. Okay. So after that, we can proceed our topic with the charged species. What do you mean by ions? Charged atom are ions, the one that carries a charge. We can say in an atom, electron that is negatively charged is equal to proton that are positively charged. Okay. Negative charge particle is equal to the positive charge particle to make the atom neutral. Right, beta? But if their number is not equal, okay, we can say that the species now carries a charge. If it carries a negative charge, that means it have gained the electrons. But if it carry a positive charge, that means it have lost electron. Right? Okay. Okay. Yes, beta. So for positive charge, electron loss is there. For negative charge, electron gain is there. Okay, so a species whenever gain or lose the electron, it will always get a charge over it by the gain or loss of electron. Okay, beta. This is all about the charged particles. Moving on to some isotoms. Very important thing. Very important thing. Very important thing. That is some isotoms. What do you mean by isotoms now? See, beta, we are right now just revising, brushing up the concept. We are just getting all the things that we did in our class. We are just revising all of them and then we will accordingly move to our question portion. There you all have to solve the question by just getting the concepts. Okay. Is it clear to you all? Okay. Okay. Okay then. So first of all, we are starting the isotope with isotopes. Okay. Isotopes. What do you mean by isotopes? Isotopes are the one that do have the same atomic number, but their mass number is different. For example, I'm taking hydrogen isotopes. Hydrogen isotopes are three in number: protium, deuterium, and tritium. The base position, that is atomic number, is same, that is 1, but the mass number is different: 1, 2, and 3. Okay, beta. So here we can say atomic number is same, but mass number is different mass number, right? Same number of proton. Now we will find out. See the atomic number. This is atomic number and this is mass number. And right now we do calculate the electron, proton, and neutron count of a particular element. So here as well, we will count the electron. Electron will be equal to proton because this is neutral only. So 1, 1, and 1. Then if I ask you about the number of neutrons, so what it will come out to be? 1 minus 1. Neutron will be A minus Z, A minus Z, A minus Z. And neutron number will be 1 minus 1, that is 0. 2 minus 1 will be 1 and 3 minus 1 will be 2. So what we can say with a more pronounced definition, that neutron number is different, electron and proton number is same. See, number of proton is same, different number of neutron in isotope. This is the question that they might ask you. Okay, fine beta. Is it clear to you all? This is how we can say electron, proton, and neutron count. Same chemical properties because they have the same number of electrons. So their chemical properties are same, but we can say physical properties, find the gradation. Okay. Moving on to generally the heavier one are radioactive in nature. The heavier one. Over here, just say we can say tritium. Tritium is radioactive in nature. Okay. And for them, what we actually did is like whose atomic mass will be taken, whether to tritium, deuterium, or hydrogen. So we do take average of all. Okay. We do take average of all. Thereby we can get the average atomic mass for them. So we do use the term average atomic mass to find out the overall mass of all the isotope they are in a species. Is it clear to you all beta? Okay, yes, fine, fine. Is it clear to you all? Okay. Now, what is the meaning of ma'am average atomic mass? Please explain us. Okay. So, yes, if I take an example of chlorine. Beta, chlorine is having two isotopes. Chlorine is having two isotopes. Chlorine number is 17. One isotope is having mass number 35 and one isotope is having mass number 37. If I ask you, do tell me what is the mass of chlorine? What is the mass of chlorine? Beta, what is the mass of chlorine? I know many of the students will answer me that ma'am mass of chlorine is 35.5. Right? That is mass of chlorine that many of you will answer to be 35.5. Right beta? Right? But that is not the case. In reality, no chlorine atom exists with mass number 35.5. That is the average mass. No atom of chlorine actually contains the mass number to be 35.5. Okay, yeah, I know that many of the students will answer me this question in this manner only, 35.5, but this is not the correct answer beta. Chlorine actually exists in two isotopic form, 35 and 37. For say the mass of the percentage of, we can say this chlorine percentage in nature, how much abundant this chlorine is. So this is 25% and this is 75%. Okay, this is 25 and this is 75. This is 25% and this is 75%. Okay, so in this scenario, we do take the average atomic mass. Average atomic mass. Average atomic mass. How? By just taking the mass number of the first isotope with its percentage, that is 75%. Adding up with the percentage and mass, 25%. Overall, by solving this thing, you will get out the answer to be 35.5. Thereby, you can say that chlorine average atomic mass is 35.5, but in reality no chlorine atom at all. You are just revising, you're learning the concept in your lower classes to be wrong that chlorine mass is 35.5. No, actually that is not the case. Chlorine actual mass is 35 or 37. We are taking the average mass of them because it occurs in the isotopic form. Is it clear to you all, beta? Okay, is it clear to you all? Yes. Fine, 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 fine. Shall we move? Okay. So this is about the isotope. Thereby hydrogen, in hydrogen case as well, if we take the average of all of them according to their abundance, we will get it out to be 1 only. That is why we are discussing always the mass of hydrogen to be 1. Some more isotopes are there. We will discuss them as well over here. So first of all, we are having with us isobars. Isobars are having same mass number but different atomic number. Okay, same mass number. For say we are having potassium and we can say calcium. Okay, right? Calcium, or we can say argon. Argon can also be taken over here as an example. Okay, right? So we can say that their mass number is same but atomic number is different. So this is the case, we can say. Okay, so different on the mass number or atomic number. Atomic number is different but mass number is same. Iso electrons contains the same number of electrons. For say we are having Na positive, Mg2 positive, Al3 positive. So all of them, sodium contains 11 electron in neutral state, but plus 1 means it contains only 10 by leaving an electron, losing an electron. Magnesium overall contains 12, but because it contains 2 plus, that means how many electrons are there with magnesium? Do let me know, beta log, in the comment section. Magnesium also contains 10 electron because 12 minus 2, because it just releases 2 electron, it just lost 2 electron. That is why it contains 10 electrons now in the 2 positive state. Similarly, aluminium also contains 10 electrons because it loses 3 electrons to get 10 electrons in its overall atom. All right, beta. Is it clear to you all? So this is how the electrons are there. We can say the isoelectrons are the one that contains same number of electrons. Moving on to next term, that is isosteres. Beta, isosteres contain electrons to be same and atomicity means number of atoms. For example, if I do talk about N2O and CO2, N2O and CO2, N2O and CO2, N2O and CO2. How many atoms are there in atomicity? Atomicity. How many atoms are there in N2O? 2 plus 1, 3 atoms. And in CO2, 1 plus 2, that are 3 atoms only. If I do ask you about the electrons, how many electrons are there in N2O? So nitrogen contain overall how many atoms? How many electrons? It contains 7. 2 nitrogen means 7 N2O. Okay, 7 into 2 because N2, okay, we are getting it to be 14, and oxygen contain overall 8 number of electron, right beta? So overall we are getting the number out to be how much? We are getting it to be 22. Same we are getting for CO2 or not? Carbon contains 6 electron and oxygen contain 8 electron, but since there are 2 oxygen, so we are overall getting it to be 16 plus 6, we are getting it to be 22 only. So in this case as well, we can say that N2O and CO2 are with what relation with each other? They are isosteres. Okay, in isotones we can say neutron number is same. I already told you how to find out the neutron. Okay, okay. Then moving on to isodiaphers. In isodiaphers, neutron minus proton is same. So there in the question, they might ask you that in this thing, what is the relation between the two species? Whether they are isotopes with each other, whether they are isotones with each other, whether they are isosteres with each other, whether there are isodiaphers with each other. So these are the different type of question that they ask you there in the concept. Okay. Okay, beta. Is it clear to you all? Fine. Is it clear to you all? Okay. Ma'am, my whole 11th is wasted because of health issues. I am thinking to repeat class 11 from dummy. Okay. Beta, in these type of question, when you are there with the backlog wala portion, you just have to, put some extra efforts by just collecting some extra time there in the daily routine, and thereby you can easily compensate the remaining portion that you wasted. That is how you can easily solve your problem. Okay. Okay, then beta, moving on to next portion, that is Dalton's atomic theory. Okay, Dalton's atomic theory. Dalton's atomic theory is the theory that actually tells us about how the atom priorly were, we can say, explained about the science, about the, we can say, that atom, how atom actually exists according to Dalton in the first theory itself. So first of all, they stated that matter is made up of the very tiny, we already know about the thing, tiny indivisible particles that are classified as atoms. Moving on to the second point, that is atoms of a particular element. As I told you, I do discuss about any element, element contains the atom that are, identical. Okay, they all are having the same mass, same size, same properties. So elements atom are identical. Okay, mass, size, and rest of the properties, that all are same only. But if we do talk about different elements, obviously their properties are different only. Atoms can neither be created nor be destroyed. You already learnt about this thing in the lower classes, that law of conservation of mass states that atom can neither be created and nor be destroyed in chemical reaction. Then if we are having atoms of different elements, they combine with each other, like hydrogen and oxygen. They are combining with each other in a specific ratio. It is not like they are randomly combining with each other. No, they are combining with each other in a fixed whole number ratio in order to form the compounds. Right, beta? Then moving on to last point, that is atom can be, see, they cannot be broken up. They cannot be reformed. They just can, what they can do? They can rearrange. They can combine with each other. Okay, they can separate out with each other in any of the chemical reaction. That is how they both are, reacting. Okay. Yes, this one shot is enough to covering all the concept that you just lack there in any topic, and this one shot is sufficient enough to cover all the concept from basic to advanced level. Okay, beta. Okay. Just after the one shot, the backlog that I will discuss in today's class, you all have to revise and you all have to do max to max question practice. That is it for this chapter. Okay, beta. Okay, shall we move? We are continuously leveling up. We are just gradually moving on from the lower topics to the advanced topic. Okay, beta, atoms, see, the old theory stated that atom is the basic thing, smallest thing. Atom is the smallest part. Atom do not contain anything small to it. But in reality, that was not the case. Atom actually contains subatomic particles that comprises the atom. Right? So this is the failure, that atom is the basic thing. No, it is not. There are more particles that are present there in the atom. Okay, beta. What thing do you want me to explain, Himanshu? Is it clear to you all? Okay. Shall we move? All right. Okay. So shifting our topic from the last portion to the next coming portion, that is atomic mass. So now what is the basic meaning of atomic mass? Ma'am, right now you told us that atomic mass is the proton plus neutron wala portion. No beta. That is mass number. This is the different thing. That is mass number having no unit at all. That is just a number. Now we are moving on with a new topic, that is mass. Atomic mass. The mass of the atom. Now, what is the basis? What is the unit that we use to find out the mass of an atom? How do we weight the mass of an atom? So, see beta, this is a very important thing, that mass of atom, because atom is very small, right? Very small. So, the instrument that we use to find it out must be very precise. For that, what we are taking is, we are taking carbon beta, carbon 12. We are just dividing. We are just dividing it in 12 pieces. 12 pieces. Okay, I'm just giving you a case where we are just taking carbon and are dividing it under 12 different pieces. Okay, we are taking a piece and that is the 1/12 part of carbon 12. We are categorizing that as 1 AMU. Okay, just taking an example, like we are having a weighing balance. Okay, just like the fruit seller uses, right? And over to one part, I am putting 1/12 of carbon 12, that is 1 AMU. 1 AMU. 1 AMU. And for the other side, whatever element weight I want to find out, I am just putting over here and finding the weight according to, with respect to, relative to that piece of carbon, whether it is 2 times of it, whether it is 3 times of it. So I am specifying one side of the weighing balance with that carbon 12, that is 1 AMU, and accordingly I am finding out the weight of the other element over the other side of the weighing balance. Is that clear to you all? This is the relative mass. This is the relative, that I am taking the relation of the element from the another one. So this is the relative atomic mass, that is RAM. Okay, that is RAM. So this is relative atomic mass, that is RAM. How to take a relative atomic mass? We just have to take the mass of the element divided by 1/12 of the mass of carbon 12. This is the relative atomic mass. This is not the actual atomic mass. This is the relative atomic mass. Relative atomic mass is not having any unit at all. So it is unitless beta. It is unitless because mass of atom in AMU, atomic mass unit, and 1/12 of mass of carbon atom is also there in AMU. So units are cancelled and overall the term become unitless. So we are having carbon not. Yes, this is another question that is very good. Why we are taking carbon only? See, this is also the main question that arises, that different elements were taken as reference. For example, hydrogen, for example, oxygen, but the most suitable one is carbon because that is present there in majority of the compounds, majority of the, we can say, different structures comprises carbon. Vast number of structures comprising carbon. It is very abundant, and the experimental proofs of carbon justifies the procedure. Okay, that is why we are taking this. Okay, beta. Okay, is it clear to you all? Okay, is it clear to you all? So atomic mass is relative atomic mass. Right now we are taking the actual mass of atom in AMU dividing by 1/12 of an atom. So what is 1 AMU? If I do ask you about what is 1 AMU, 1 AMU is 1/12 of mass of carbon 12. Right, beta? 1/12 of mass of carbon 12. Now carbon 12, mass of carbon 12 is 12 gram. That is overall mass of Na particles. What is the thing? See, Na is Avogadro number. Okay. Na mass, carbon 12, Na particle mass is how much? Na particle mass is 12 grams. I'll explain it to you once again. If I do take an example of carbon only, carbon Na particles, Na is how much? Avogadro's number. Okay, so atoms of carbon that are Na in number, their mass is 12 grams. Okay, if I want to take the mass of one carbon, so it will come out to be one carbon atom mass will come out to be 12 upon Na in grams. Is it clear to you all? Is it clear to you all? See, Na atoms mass is 12 gram. So one carbon atom will be 12 upon Na in gram only. So I am writing over here 12 upon Na. Is it clear to you all? Let me explain you once again. 1/12 of mass of carbon 12 atom. is 1 AMU. So 1/12 of mass of carbon 12 atom. Carbon 12 atom. So what it will be in grams? It will be 12 by Na. So 12 cancel with each other, and I am getting 1 AMU to be equal to 1 by Na in grams. We can write it as 1 by 6.022 into 10 raised to the power 23 in grams. On solving it out, I will get the value to be 1.67 10 raised to the power minus 24 in grams. So this is how we can relate the AMU unit with gram unit. Is it clear to you all? So this is how the relation exists. 1 AMU is equals to 1.67 into 10 raised to the power minus 27 grams. Is this thing clear to you all, beta? I'll repeat the concept. I'll summarize the concept. What is the atomic mass that we discussed so far? First is the relative atomic mass. RAM. Relative atomic mass relate the structure. We can say relate the masses. The actual mass compare with the another element, that is carbon 12. 1/12 of carbon 12 is there in the weighing balance, and we are just finding out the mass of element by just relating it with the mass of carbon 12. Okay, so this is how I am just writing the relative atomic mass of any of the element. Now I have related the 1 AMU unit with grams unit. How? I already told you what is 1 AMU. 1/12 of carbon 12 piece is stated as 1 AMU, and 1/12 of carbon 12 mass is 12 by Na in grams of one atom. So I am just writing it over there, and on solving I'm getting the AMU relation with gram relation. Is it clear to you all, beta? And Avogadro number 6.022 in 10 raised to the 23. We'll discuss about Avogadro number in more detail in the upcoming portion. Okay, beta? Just note it down and do let me know in the comment section if you all are having any problem in any portion so far. I'm there to help you all out. I want my student to like the session as well. Whosoever is attending our session, I want to, I want each and every one of you to mark your attendance by hitting the like button, so that I can see that how many of you are dedicatedly following the JEE Main session. Yes, beta? Okay, all right. Moving on to the next portion, shall we? Is this clear to you all? Okay, beta? Okay, what are the chapters that you're gonna cover? Beta, first of all, subscribe to this channel. If you are new to this channel, subscribe to this channel, because we will be actively working over to this channel. If you are a JEE aspirant, first of all, subscribe this channel. We will work on this channel. We will bring that backlog series. After that, we will bring one-shot series as well. We will do massive practice over here. So you will get the schedule on a timely basis over the community post in this channel only. Okay, so just stay connected with us. There in the description, you'll get the description, you will get the Telegram channel links and all. So you can connect with us, and on a regular basis, there is a lot more session conducting in this channel only. Can we relate it with another element? Yes, sure, why not? If we do take an example of oxygen, beta, oxygen 16 element. So with respect to oxygen, 1 AMU is what? 1 AMU is what with respect to oxygen? If I do take an example of other element for say oxygen, with respect to oxygen, if I relate it with oxygen, so 1 AMU is 1 by 16th, है ना? 1 by 16th of oxygen 16 atom. Okay, beta? 1 by 16th of oxygen 16 atom. With respect to nitrogen 14 as well, we can take it out to be like 1 AMU 1 by 14th of oxygen 14 and oxygen nitrogen. With respect to hydrogen, we can also take it to be like 1 AMU is equal to complete hydrogen atom mass. Okay, so that is different forms that we can use with respect to the element that we are using. All right, beta. I think this is clear to all of you, right? Moving on to a question portion. We'll see how many of you are capable of doing this question. Calculate the actual mass. Beta, relative atomic mass is not having any unit at all. If I do ask you about the actual mass of nitrogen atom, so here you must have learned that nitrogen mass is 14. Now what is the unit that we use for it? Since we are discussing about the atom, beta, atom is having a very small unit because atom is very small particle. So it will come out to be AMU, right everyone? 14 AMU will be the unit of nitrogen atom. But if I want to take it in grams, it will be like 1.67 into 10 raised to the power minus 27 in grams. Right, beta? Minus 24 in grams. Okay, minus 24 in grams. If you want to take it in kilograms, you can accordingly divide it by 10 raised to the power 3 to get it in kilograms unit. That will be minus 27 then. Okay, is it clear? For nitrogen atom. If I ask you about nitrogen molecule, beta, molecule means you have to see that how the structure actually exists. Okay, how nitrogen actually exists. So in usual state, nitrogen exists as N2. So N2 means 2 into 14, that is 28 AMU. If I'm writing AMU, that means it is actual mass, right? If I want to take it in grams unit, it will come out to be 28 into 1.67 into 10 raised to the power minus 24 in grams. So this is how you have to answer your question accordingly. If I ask you about the relative atomic mass, RAM, so what it will come out to be? RAM will come out to be that is 14 only. Okay, that is 28 only. So RAM of nitrogen is relative atomic mass of nitrogen atom is 14. Relative atomic mass of nitrogen molecule, better tell me there in the chat section. I want each and every one of you to answer me the question, right? Yes, so it will come out to be 28 without any unit. All right, beta, is that clear to you all? Shall we move? Is it clear to you all? Shall we move? You want me to move to the next topic or any doubt in this portion as of now? Right? On a similar basis, yes, beta, we can write it like this as well, or we can write it like this as well, 14 by Na in grams, or we can write it like this as well, 28 by Na in grams. Very good, beta. This is also the method we can represent in terms of Na as well. Okay, Avogadro's number. All right, in a similar basis, as we discussed about the average, as we discussed about relative atomic mass, on a similar basis, we are having the average relative mass compared to the so it is also relative. Molecular mass is also relative. That means the mass of molecule with respect to 1/12 of carbon 12 mass. Okay, so that is relative molecular mass. Also, it is not having any unit. It is again unitless because it is compared there with carbon 12. So we are taking it as relative molecular mass because right now we are having any molecule. For example, if I do take an example of H2O, beta, H2O. So 2 into hydrogen mass, that is 1. Oxygen mass, that is 16. So it will come out to be 18 AMU. Now, since it is not an atom, so we can write it as U. That is unified mass. Okay. Overall, we can write in place of AMU. AMU is also there, but more pronounced term is U, that is unified mass, that is used for all the species that are very small in size. Okay. Okay. Is it clear to you all, beta? Similarly, if I do ask you about C6H12O6, Do let me know in the comment section what is the answer that you are getting. What is the molecular mass of C6H12O6? Yes, beta. What is the molecular mass of C6H12O6? I want you to answer the question that what is the molecular mass of C6H12O6? Do let me know in the comment section. Then after that, you can also find out about H2SO4. If you are done with the question C6H12O6, do let me know beta what is the molecular mass of H2SO4. If they specifically ask you about relative only, then no unit will come. Tell me beta, C6H12O6, what will be the molecular mass of C6H12O6? Very good. Okay. Without any difference with actual mass. Relative, yes. Almost it will be same only. There will be slight difference in the relative and actual value, but that two comprises approx value to be the same only. Yes, beta, very good. Nitish and Abdullah Khan, very good. That is your answer. See, overall the answer over here C6H12O6 comes out to be 180 only. Okay, because 6 carbons are there, right beta? 6 into 12. 12 into hydrogen number is 1 and 6 into oxygen that they are having 16 atomic mass. Okay, so overall the number will come out to be 180 only in U units. Okay, in terms of H2SO4, it will come out to be 98. Very good beta. Very good. This is how you have to answer the questions in exam as well. It is very simple. You just have to follow the trend, follow the sequence. Okay, so that is it about the main basis that we did so far. Now we will start with the portion that is mole concept. As of now, whatever we did was the base of the portion that is mole, because many of the teachers might not tell you about the portion that we did so far. But for my students, I want each and every one of you to be familiar with all the terms that we did so far. And I believe that all the things that we did so far are very well clear to you as of now, isn't it? Okay, so are you all excited for the next topic, that is mole concept? Shall we start? Okay then. Mole concept beta. What is the use of mole? Why we are using mole? What is the main meaning of mole? So first of all, mole is just to make our calculation more simplified, right? How we can say so? Just take an example of different terms that we use in our daily life. For example, if I'm taking 1 dozen, what is the meaning of 1 dozen? Yes, ma'am, we know that what is the meaning of 1 dozen? It is 12 pieces of anything. 12 pieces of pen, 12 pieces of banana, 12 pieces of apple, 12 pieces of chair. When I state 1 dozen, the thing that strikes there in your mind is 12 pieces of anything, right beta? Similarly, if I do ask you score is for 20 article, gross is for 144 article. On a similar basis, 1 mole is what? 1 mole is 6.022 into 10 raised to the power 23 particles of anything. It is not like only electron. It is not about only atoms. No beta. If I state 1 mole, it simply represents that we are combining this much particles and that comprises 1 mole. Alright. So from now onwards, your main task is to become molepati, isn't it? Not crorepati. We are chemistry students. Our aim is to become molepati. Somebody will say that, ma'am, we want to become crorepati. No, you all will become molepati. Molepati means you will earn rupees, that is 6.022 into 10 raised to the power 23. That is the rupees. Right? So this is the task. This is the aim of all the students that are there in our class. Okay, so from today itself, if I ask you that what is your aim, you all will say that, ma'am, we want to become molepati. We all want our bank balance to be how much? 1 mole, ma'am. How much 1 mole? 6.022 into 10 raised to power 23, ma'am. That is a very huge number. You all will have to put a lot more effort to get that number, right? But yes, I think that you all will be able to get it. Okay. So yes. Okay. Break. Bit of 7. Okay. At 7:30 we will take a break. Okay. 7:30. We'll take 5-minute break. No issues. Pati means rupees. Yes, you can say so, Vishnu. Okay. Okay, beta. So this is about mole. Whatever we will say that if I do ask you about 1 mole oxygen atom, that means we are having 6.022 into 10 raised to the power 23 oxygen atoms. Okay, beta. 1 mole H2O. That means we are having 6.022 into 10 raised to the power 23. H2O is a molecule. So we are having this much molecules of H2O. Is that clear, beta? If I do ask you about 1 mole nitrogen, since nitrogen exists as N2, that means 6.022 into 10 raised to the power 23 beta molecules, because N2 is a molecule of nitrogen, N2. If I do ask you about 1 mole O2 minus, that means 6.022 into 10 raised to the power 23 ions of O2 minus. Right, beta? If I do ask you about 1 mole electron, 1 mole electron, that means 6.022 into 10 raised to the power 23 electrons. So wherever I use a term mole, that simply represent that I am taking the case where the particles, whatever these particles can be, they are in this number. And what we state the number to be as, this number is Na, that is Avogadro's number. So I don't again and again have to repeat this number. I can simply write Na over the position of this number. That means Avogadro number. Remember, it is capital A, not small a. Okay. Is it clear to you all? Okay, beta. Is that clear to you all? Okay. Fine. Yes, okay. So this is the basic definition of mole. Wherever I use the term mole, that simply means we are combining these much particles. They can be anything and we are simply writing them as like this. Okay. Now if I do talk about the mass of them, there is no such difference between the mass of the atoms, the molecules and now the moles. The unit difference is there. Since let us say oxygen atom, 1 mole is taken beta, 1 mole, 1 atom mass is how much? 1 atom is 16 AMU. And if I want to change it in like mole, mole means we are having these much atoms. 1 atom mass is 16 AMU and Na atoms mass is into Na, right, in AMU. That will come out to be 16 gram only beta. Is it clear to you all? Is it clear to you all? I'll repeat it once again that 1 oxygen atom mass is 16 AMU. We are having Na oxygen atom in 1 mole. So the mass of 1 mole oxygen atom will be Na times of 1 oxygen atom, that is 16 into Na in AMU. But if you want to convert it in grams, you just have to divide the term by Na, right? And you will get it in grams only, right? Remembering the concept, because I told you AMU, 1 AMU is equals to 1 by Na grams, right? This is the relation. So this is how you can convert it out. Similarly, H2, it is 18 AMU, the mass of 1 molecule, into Na, the mass of Na molecules. In terms of gram, it will be 18 grams like this. Just divided by Na and you are getting the answer, right beta? Simple as that. Moving on to next, 1 mole of nitrogen, N2. N2 means 14 into 2, beta, 14 into 2, that is 28 AMU. I'm writing it over here, 14 into 2 AMU That is the mass of one molecule. But if I am multiplying it by Na, I will get the 1 mole nitrogen mass. In terms of gram, it will come out to be 28 gram will be the mass of 1 mole of nitrogen. Is it clear to you all? Yes, beta. Moving on to 1 mole of N2 minus, O2 minus. That is simply an ion. Just simply write it out like this only, like 16 gram for oxygen, and electron is 9.1 into 10 raised to the power minus 31. Right? It is the mass of one electron, isn't it? In kilograms. In kilograms. If I do multiply it by Na, I will get it out in kilograms only, to be like this for 1 mole electron. Okay, beta. Is it clear to you all? This is how you can solve any of the question of mole. Okay, beta. Similarly, if I do ask you about 1 mole C6H12O6 glucose, so it will be 180 gram. Okay, so this is molar mass. Molar mass is the mass of 1 mole of the particular species, whatever we are using, that is molar mass, the mass of 1 mole of a particular species. Is it clear to you all, beta? Is it clear to you all? Ma'am, please repeat it again. Beta, what do you want me to repeat? I just stated over here the mass of moles. Okay, just have to write the same value, only the unit will change, that is grams. In place of AMU, just you have to write grams, and that is how you will be able to find out the mass of mole of any of the component, as simple. Is it clear now? Okay, shall we move? Okay, okay, done with the part, done with the session. Okay, moving on to next thing. See, as I told you, definition, what is mole? Now we will discuss about the mole, that how do we find out the like 1 mole, why is it so? Why this 1 mole is equals to 6.022 into 10 raised to the power 23 particles? Why not any other thing? Right? Because we are taking with a container, let us say this is the container. Over the container, we are having carbon 12. Okay, we are having carbon 12. We are having carbon 12. And the weight of carbon 12 taken over here is 12 grams. Okay, just listen to me carefully. What I'm telling to you, that beta, we are having, let us suppose we are having a container. In this container, I am putting carbon 12. And the weight of carbon 12 that is taken over here is 12 gram. That I am weighing it. 12 gram is the weight of the particular thing. Now, I am just marking this value and counting the number of atoms. Okay, I know the mass of one carbon, and accordingly I will find that how many atoms are there in 12 grams. Is it clear to you all, beta? When I found that the 12 gram comprises how many atoms, the number is coming out to be 6.022 in 10 raised to the 23. That is Na atoms. Avogadro number. From there, I am getting this value. Have you ever imagined why we are using only this value, not any other simple value? There is a reason why we are using this value, because carbon 12 we are taking as a reference. We have taken the weight to be 12 gram because I know the weight of carbon is 12 only. So, I am taking 12 gram carbon and finding out that how many atoms are there in 12 gram of carbon 12. That is 1 mole. The number comes out to be this only. So, these are the atoms present in 12 gram, that is 1 mole. So, we are marking it as 1 mole. Okay, beta. So, what is mole? The amount of substance that contain as many particles. How many? As many particles that 12 gram of carbon atom contain. That is 6.022 into 10 raised to 23. That is 1 mole only. So, this is the relation. This is the definition. I think that I'm just wishing that the thing I'm explaining to you, you all are getting the concept. You all are getting what I am trying to explain to you all, guys. Is it clear to you all or not? I want that my student must be much more familiar with the concept. They just don't cram the concept, they are revising, they are actually getting the concept that why we are using the specific number only, why not any other number, because this number is the identity that 12 gram of carbon contains this much number only. That is why we are marking that as 1 mole, not any other number. Okay beta, is it clear to you all? Okay. Yes, beta Vishnu. 1 mole H2 plus 1 mole O2, 1 mole H2O or 2 mole. Okay. One question is there, 1 mole H2. 1 mole H2. Okay. And 1 mole O2, oxygen. It will comprise overall beta 1 mole H2 and 1 mole oxygen will overall make 1 mole H2 only. Okay, Vishnu. Any other doubt? Any other doubt so far? Is this clear? Okay, beta. So this is about mole. Okay. Then we will discuss about the certain terms that we use for mole only. Mole and gram molar mass. Beta, see, this thing is very important for all of you. Mole, as I told you, mole mass is, mass of mole is named as molar mass. Molar mass. Okay. Now, if I do talk about, we are usually taking the molar mass in grams only. Right, beta? One term is introduced, gram atom. What is gram atom? What is gram atom? Gram atom means 1 mole of atom. For example, if I'm taking an example of 1 gram atom oxygen, that means we are having 1 mole oxygen. That means the mass of oxygen is 16 gram beta. Is it clear to you all? Correct, and everyone? But that means we are having Na oxygen atom. 6.022 into 10 raised to our 23. Right, beta? If I do take another term, that is gram molecule. Gram molecule means 1 mole of that molecule. For example, I'm taking 1 gram molecule oxygen. Now decode this term. 1 gram molecule oxygen. Now what is the meaning of gram molecule, ma'am? We are clear or not? See, 1 gram molecule oxygen means we are having 1 mole oxygen molecule. Beta, how oxygen molecule exists? It is like O2. So you all have to decode this term, that 1 gram molecule oxygen means, ma'am, it is not 1 mole O, it is 1 mole O2. This is different from the previous scenario because there they stated atom. So we are taking it as atom, single piece only. Here we are having molecule. So molecule mean O2. Okay, then we are having the mass to be 1 molecule. We can say 1 mole means Na, Avogadro number, molecule of O2. And the mass will come out to be how much? Because oxygen is having the mass of 16 gram, but O2 is having 2 into 16 beta, that is 32 gram. 32 gram. So there is a difference between the two terms that I stated you. Gram atom doesn't mean gram in gram in gram. No beta. Gram atom means we are specifying the thing as 1 mole in terms of their atom. Gram molecule means 1 mole. Wherever you find gram atom, that means it is 1 mole only. Where that means it is mole only. Wherever you are finding gram molecule, that means it is molecule in mole only. Okay, I will explain you with more examples because this is very important thing and many of the students might make the mistake while solving this type of question. But I am here to help you all out. We can continue the part, or you want me to give a 5-minute break, beta? Do you want me to continue with the part, or do you want me to give a 5-minute break? What is your call? What is your call? What is your call? You want me to continue, or you want me to give a 5-minute break? whatever is your call, I'll do accordingly, because I am fine with the okay, break. I can see the comment. Break. Okay, so I think that you want a break. 5-minute break is fine for you all, guys, right? I think a 5-minute break is fine for you all, isn't it? Okay, so I can do one thing. I can give you all a 5-minute break. Okay, get a second. 5 minute only, okay? Not more than that. 5 minute is fine for you all. Total duration is better of 3 hours. 3 hours. 3 hours. You want me to give a 5-minute break? I am giving you 5-minute break, but not more than that. I'm just giving you a 5-minute break because many of the students were there from the starting 6 p.m. So I want that you can also relax by your own. No, it's not an issue, better. Just giving you 5-minute break. Okay. So starting up with the timing. Okay. Waiting for 5 minutes. Coming back in 5 minutes. You can also have some water and all, and we will continue with the topic. Okay, beta? But don't go anywhere else. I'm telling you. Okay. Bye bye. Coming there in 5 minutes. Okay, hello, hello, hello. Can you all hear me out? Yes, everyone. Am I audible to all? Okay, so let us continue our topic where we left. Expected duration better 9 till 9, max 9. Before that, we can also do this thing. These type of one shot for every chapter. Okay, sure, beta. We will definitely bring these type of one shot for every chapter only. But all I need is you all guys should all be active there in the channel. That's it. Okay, you all should attend the session with proper dedication, discipline, and I think I'm looking over here over the comments that many of the students are just, they are fab. They are just attending the lecture with proper dedication, with proper motivation, and continuously giving me the answer of all the questions that I asked there in the session. Okay, yes, so let us continue the session. Okay, beta, so as of now, as I told you, that gram atom, that means not atom in gram. No, 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 nothing like that. Gram atom mean we are taking 1 mole of that. Gram molecule mean we are taking 1 mole of that. Okay, we will do the questions as well, but before that, I'm just telling you the mole relation, and then we will do all the possible type of mole questions, beta. That what is mole relation? Suppose they are giving us what? They are giving us the mass, and they are asking that tell us that how many moles comprises this much mass of the element. See, I will just tell you the relation that we gonna use in different type of question. First of all, we will use mole to mass relation. Mole to mass relation. That means mole is equal to given mass by molar mass. These are just that to help you all by easy up your calculation, by simplifying your calculation. It is, just the formula is created to simplify your calculation. Otherwise, without the formulas also you can solve the question. But these are just to simplify the calculation. First relation is mole to mass, that if the mass is given to you, mole they are asking, you can use the formula. If the mole is given to you, mass they are asking in the question, you can use the formula. Then the second is mole to number relation. Number relation. Wherever they are asking about the number, beta. Number is like, for say, given particle number, given number of particle upon Avogadro's number. Remember Avogadro 6.022 10 raised to power 23. Avogadro's number. Now the particle is what? Whosoever mole is given to you. Right, beta? It can be anything. It can be atom. It can be ion. It can be molecule. It can be anything. It can be anything. It is not specifically restricted there to a particular thing like atom. No, whatever thing is 1 mole of atom. So that means you have to say that particles over there is atoms. 1 mole of ion, 1 mole of electron, proton, neutron, whatever the thing is there, particle can be adjusted accordingly. Then the third relation is mole to volume. Mole to volume relation. Mole to volume relation. Beta, mole is equal to given volume upon 22.4 at STP. Remember, at STP we say that 1 mole of anything, any gas at STP comprises the volume to be 22.4. According to old terms, according to modern term, it is 22.7. But yes, in majority questions, we do use this 22.4 only in liter. In liter per mole. Okay, this is liter. Okay, and here the mass is gram and molar mass is gram per mole. So thereby you can use the term accordingly. Is it clear to you all, beta? Yes. Okay. Yes, beta. Is it clear to you all? So now we are having three formulas, three different formulas of mole. We can collectively merge up these formulas because all the formulas are there of mole. If I am finding out mole from volume, I do use this formula. If I find out, if I want to find out mole from particle, I do use this formula. But if there is a relation between, let us say in a question, they are asking about volume and they are giving you the number. So these two formulas you have to combine there with each other, right? If they are asking you about mass and giving you the volume, you have to merge up these two formulas. So now I am writing down the collective formula that all of them are the mole formula of only. So it will be given mass upon molar mass. It will be given particles. It will be given particles. Particles can be anything by Avogadro number. Simply I'm writing Na, right? Just a short form of it. Given volume. Given volume upon 22.4 liter. That is how you have to given volume at STP. Remember, without STP, you cannot use the formula. STP, NTP, whatever the condition given to you, you just have to sum them all up and together list them all like this. They all are equal to each other as well in the formula. Is it clear to you all, beta? Is it clear to you all? Do let me know in the comment section. Right now, we will solve n number of questions so that we can excel in this mole topic. Right, beta? Okay. Just mark a thumbs up there in the chat section. I need my student to be active in the session. How will you feel like ma'am will be like, teaching you the session in a very loose, lazy way? No, na. Ma'am is super excited. Ma'am is super motivated. Ma'am is super energetic. So I want my student as well to be energetic just like the ma'am. Right? So I want each and every one of you to be active there in the session. Beta, this is English channel. So that is why ma'am is using English language to teach you there in the English portion only. Okay, so this is the English channel. That is why if you are not getting the concept in English, so this is quite limitation for you, beta, but this is English channel. So that is why we are using English term only. But I think that these things are clear to you. If you do attend the lecture from start or from the new topic, you also will be able to capture all the points that we did so far. Yes, beta. Okay. So let us practice some question now, right? Are you all excited for a new question practice? Let us see that how these confusing questions can be easily simplified by just simple formulas. See, calculate the number of moles. They are asking about moles. What they are giving to you is mass. So remember the number of moles, given mass by molar mass. I am just using the short terms. Okay. So over here, given mass is 5.5. Given mass is 5.5. And what is the molar mass of CO2? See beta, CO2, carbon is 12, oxygen is double in number and the mass of oxygen is 16. So together, what is the overall mass that you are getting over here? You just have to add it on and you will get it to be 44 to be the molar mass of CO2, and by subsequently solving the question, many more questions, these molar mass will be all in tips for all of you guys. So that is about CO2. This is how you have to solve and you will get the number of moles. As simple as that. 12 gram of carbon atom, beta, carbon atom. So number of moles will be 12 gram. Again the mass given to you, that is given mass by molar mass. Given mass is 12 and molar mass is again for carbon it is 12. So you will get the number of moles to be 1 mole. This is mole. Moving on to next question, beta, 12 gram atom. There's a difference. It is gram. It is gram atom. That means, as I told you, gram atom is equal to mole only. So if we are having 12 gram atom, that means we are having 12 mole. And they are asking us about mole only. So your answer will come out to be how much? 12 only. Okay, beta, is it clear to you all? Moving on to next. 1.12 liter of CH4 at STP. Now the volume is given to you, beta. So number of moles formula will come out to be given volume by 22.4 liter. Right? So here at STP you always have to take the volume. So 1.12 liter of CH4 at STP. Yes, it is given, then only you can use this formula. Otherwise, This formula is not suitable for any other type of question. So here you will write it out to be 1.12 liter divided by CH4, see 22.4 respective of any other gas. You just have to see that whether it is a gas or not. CH4 methane is obviously a gas at STP given to you. So you just have to write it like this, and accordingly it will come out to be 1 by 2, right? So 1 by 20. So this is how you have to solve it out. You just have to solve the question of mole in a manner to find out that whether mole relation with mass is given to you, with volume is given to you, or with number of particle given to you. Then is this much molecules of ammonia beta. So again, I'm using over here the number formula because molecules of ammonia given to you. There's a number given to you, 3.01 into 10 raised to the power 23 molecule divided by Avogadro number, that relation given particle by Avogadro number 6.022 into 10 raised to the power 23. So it will come out to be 1 by 2 and 23 it will be cancelled up. 0.5 mole will be your answer. Is it clear to you all beta? Is it clear to you all? Is it clear to you all? Yes beta. Is it clear to you all? Okay, so let us try other questions. I think these questions are clear to you all. Shall we move? Okay, beta. Calculate number of moles. 6 gram of urea. First of all, for those students who don't know the formula of urea, you will not be able to solve the question. So this is urea beta. Okay. So 6 gram of urea. Number of moles will be given mass by molar mass. Given mass given to you is 6 gram. And with the molar mass of urea, beta, urea is, this is the formula of urea. And if you do find it out, you will get it out to be 60 gram per mole. Right, 60 gram per mole, and on solving you will get it out to be 1 by 10, that is 0.1 mole. Okay, this is how you have to solve the question. 3.42 gram of sucrose. So formula of sucrose is C12H22O11. Until and unless you are unaware about the formula, you won't be able to solve the question. So first of all, you do have to revise the formulas, then only you will be able to solve the question. So ma'am, how to do so? How to know which formula we have to revise and which do not? So first of all the questions that we will cover over here in your DPP, in your practice sheets, in your book modules, whatever you are using as reference, all the things that are there, all the formulas that are there, just keep on revising them. Then only you will be familiar with different type of formulas that you came up with. Okay beta, so this is the formula, and if you do solve the molar mass of it, it will come out to be 342. Right, as I told you, these formulas, these molar mass will be on your tips after subsequent practice session. Okay beta, so number of moles will be given mass again by molar mass. Given mass is 3.42 and accordingly molar mass is 342. 1 by 100, 0.01. That will be the mole count. 8 gram of oxygen. Now what oxygen? Whether oxygen is oxygen O or O2. Beta, it is not given over here anything like atom or molecule. So accordingly, in these type of question, you yourself have to consider oxygen as in the form that it exists there in nature, that is O2. So here you will write number of moles is equals to given mass 8 gram upon molar mass of O2. O2 will be 2 into oxygen atom, that is 32 in this case. Is it clear to you all beta? Okay, so this is how you have to solve, which is 0.25. So this is how you have to solve the question. Okay beta, whenever it is not given to you, you just have to simply write it in the molecular form that it exists. Otherwise they will specifically mention atoms like thing. Okay. Okay, moving on to beta. Is it clear? I want each and every one of you to put that thumbs up there in the session. Otherwise, we will just wait that how many of you are actually getting the concept. Just put a thumbs up and click that like button as well. I want each and every one of you that are attending our session to click that like button so that I'll get to know that yes ma'am, we are dedicatedly following the session. Yes ma'am, we are getting the concept, because these type of questions are very confusing beta. Some people like how to find out oxygen atom are there or oxygen molecule are there. So these type of questions are very crucial for all of you, and these are all we are solving, right? So moving on to next thing, that is calculate the number of moles in each of the following, and I want you to solve it parallelly and answer me that in the chat section. Moving on to number of molecule in the following beta, 16 gram oxygen. Right now I told you whenever it is not mentioned that atom are there, you always have to take its molecular form, that is O2. So here number of moles given mass by molar mass, given mass is 16 and molar mass is 32 because O2 are there. Accordingly you will solve it out. Okay, moving on to next, 7 gram of nitrogen. Again, no atom is mentioned, but we know that nitrogen exists as gas, N2. So we have to write it like N2. Number of moles will be 7 upon May to N2, that is 28. So gram, and it is gram per mole. It will come out to be 7 by 28, 1 by 4.25. Okay, so this is the mole calculation. Moving on to atoms of carbon. Beta, atoms of carbon. Atoms of carbon, number of moles given particles by Avogadro number. Because number is given to you. 1.5 into 10 raised to the power 24 by Avogadro number 6.02 into 10 raised to the power 23. This is how you have to solve the question. Okay, beta. Yes. Moving on to molecules. Again, in molecules, this will be this much amount divided by Na. Means number of moles will be 3.01 into 10 raised to the power 21 upon 6.02 into 10 raised to the power 23. Accordingly, you can solve it out. Now, a very important thing that this is centimeter cube. Ma'am, we are unaware about centimeter part. What is centimeter cube? So I'll explain you with the help of certain units. See beta, 1 meter cube. These all are the units of volume. 1 meter cube is equals to 1000 liter. And liter is equal to decimeter cube. And we know 1 liter is equals to 1000 centimeter. This thing you know, right beta? And centimeter, 1 liter is equals to milliliter, this much milliliter, and milliliter is equals to centimeter cube. We can also write it as cc, cubic centimeter, cc. Okay, so these are the basic unit thing, volume unit thing that you all need to know, because many times we do confuse with the volume conversions, right? So here they are asking centimeter cube, that means 112 ml, right beta? In the formula of number of moles, I told you about given volume in liter upon 22.4 because it is liter per mole, right beta? So here we have to write it in liters, but if ml is given to you, you can convert either this to ml or you can convert either this to liter. Any of the thing you can do. So if I am taking it in terms of ml only, so 112 ml upon 22400. I can write it as 22400 as well, 22.4 liter, right? So 22400 ml per mole. So this is also because obviously ml will be cancelled and we will get the answer in mole only. So this is how you have to solve the question depending on the units beta. Okay? Right beta? Okay beta. Finding out the another question, calculate the number of atoms. Now the another question arises. Number of atoms. See, as I told you, number. How to find the number? Molecules are given to you, given particles by Na. And if I want to find out the particles, given particle by Na, particles can be calculated by multiplying the moles with Na, right? But if I want to find out the atoms, accordingly I have to see that if molecule is given to you or what is given to you. 0.5 mole of oxygen. Beta, oxygen is what? O2. We all know. Oxygen is what? O2. If I find O2, the particle is molecule, right? Because O2 is molecule. So if I use the formula, we can find the molecule to be like number of moles into Na, right beta? Number of mole given to you is 0.5 Na. I'm writing in terms of Na only. I'm getting number of molecules because O2 is molecule. Now if I want to find atom, so I can see in one O2, 2 atoms are there. So in whatever the molecules are there, atoms are how much? Atoms are how much? Atoms are to double of the number, that is 0.5 Na. Is it clear to you all? This is how you have to solve this all out. Okay, you're getting it to be Na only. Find it out, that number of 0.5 mole of oxygen atom. Now they are giving you oxygen atom. That means here in term of particle you will write what? Atom, N into Na. Number of mole given to you is 0.5 and Na is Na only. So this is how you have to solve the question beta. Okay beta, whatever is your requirement beta, please mark my word, whatever you want me to solve, like you want either the practice question, you want the PYQs portion, you want the theory portion, whichever chapter you want, do let me know there in the comment section after the video and after the session end. Please ask your queries there in the comment section. It will always be active for all of you guys, and we all and the team are personally reading all the comments and will definitely help you resolve your problem. Okay, so don't worry in that. 0.5 gram atom of oxygen. Now see, gram atom, as I told you, it is not gram, it is mole only beta. And gram atom given to you, that means you have to take oxygen single over here. The 0.5 mole oxygen atom given to you. So here you have to find the atoms as mole into Na. So mole is how much? 0.5. Na will be the answer. Similarly, gram molecules means molecule is there and molecule exists as O2. So here we are having, first of all, because O2 is a molecule, so according to molecule we have to solve it all out. So molecule will come out to be mole into Na, and mole is 0.5 into Na, but we want in this question to find out the atom. So atom, in one molecule 2 atom are there, and in X molecule 2x atom will be there, means we have to multiply this 0.5 Na term with the 2 to get the number of atom. Is it clear to you all beta? Next is 1.12 liter of nitrogen at STP. That means over here again mole we need to find, but beta first of all here see, in this question they are giving you volume, right? They are giving you volume, and what you need to find is atom. What you need to find is atom, that means particles. N into Na, number of moles. Do you know number of moles? No ma'am, we know volume. Do you know the relation between number of moles and volume? Yes ma'am, we know. So you can simply replace the N term over here by given volume by 22.4 at STP into Na. So you can use this formula to find out particle as well, because you know the volume, you don't know the mole. Either you first of all can find out the mole and then you can put the value over there and find the particles. But here you can simply use this formula as well. So depending on your comfort zone, you can switch the formula accordingly. All you need is maximum practice on these type of questions beta. Now 1.12 liter of nitrogen at STP. You just have to know that nitrogen is N2 first of all. Okay, N2. Now you just have to put the values of atoms. Right? Why I am writing molecule over here? Because N2 is a molecule. As I told you, particle is not specified. It always depends upon the type of question that they frame. If they are giving you the molecule, particle will be molecule. Okay, so it will be N into Na, and in place of N I am replacing the formula with volume term. So given volume by 22.4 into Na is the molecule you are getting, and if you want to find out the atom, you just have to multiply it by 2, because one molecule contains double atom. So atom will come out to be 2 times of this formula. Given volume is 1.12 by 22.4 into Na, you will get the atoms number. Okay, is that clear to you all beta? I want you all to solve the question and parallel tell me that answer in the comment section beta. Okay, so 0.5 gram of oxygen. Now what is this oxygen? 0.5 gram of oxygen. Oxygen, okay, grams is given to you, gram is given to you, so just have to replace the mole term with the gram. Given mass by molar mass into Na. In this N, that is number of moles, you just replace the term as well, beta. Okay, so here 0.5 gram oxygen, oxygen is O2. So first of all, you will find the molecule that will come out to be given mass, that is 0.5 by molar mass, that is 32 into Na. Right beta? So this is the molecule, and for atom you have to just multiply this by 2 and you will get the, in place of molecule you'll get the atom, because in one molecule we are having two atoms, and whatever the molecules come, you just have to multiply that term by 2 and you will get atom there. Fourth one, beta, gram molecule. Gram molecule always mean mole. Gram molecule always mean mole. Gram ion, gram molecule, gram atom, that always mean mole. So wherever they ask gram atom, gram molecule, that means mole. Means they are giving you 0.5 mole O2. Gram molecule. Molecule means oxygen is in the molecular form, O2 form. Gram atom means oxygen is individually in atomic form. So that is the difference. So we are having 0.5 mole, and from mole we can find out the molecule by multiplying it with Na. That's it. Is it clear now, beta? Okay. Okay, moving on to another question. 3.2 gram of sulfur. Beta, atom. Atom is like 8 times of the molecules that we are getting. So the molecular formula is multiplied by 8. We are getting the atoms then. Okay. So here we are just taking the same formula that we did. Given mass by molar mass into Na. This was the formula of number of molecules, and if I do multiply it by 8, because 8 atoms are there in one molecule, I'll get the atoms. So 8 into given mass is 3.2, and sulfur molar mass of S8, 8 into sulfur mass, that is 32. Okay beta? Okay, into Na. This is the formula that we can apply over here. Okay beta? Beta, these why are you typing this type of, ma'am, you are 1 by cosec, ma'am, 1, okay, ma'am, why are you 1 by cosec? Beta, these are maths type of things, and I know what you are trying to frame there in the comment section, right? Okay, just moving on to the move to our part, what we were discussing. Okay, 8 gram of oxygen atom. Again, 8 gram of oxygen atom. How to solve? 8 gram of oxygen atom. Oxygen atom is single O. Right, beta? Okay, beta. 1 gram of, 8 gram of, yeah, except 2 or 3. Okay. 8 gram of oxygen atom. Oxygen atom is O in individually. So if we want to find out the atom will be number of moles into Na, and number of moles, in place of number of moles we are provided with the mass. So given mass by molar mass, in place of number of moles I am using this formula into Na. So given mass is 8, molar mass of O2 is 16, and Na, right? So Na by 2. Na by 2 or 0.5 Na, you can write it like this as well. Whatever is the option, you can see that whatever the option given to you, accordingly you can frame your answer in that sentence. 1.5 in 10 raised to 20 molecules of oxygen. Molecules, see, molecules given, that means it is O2. Right? So if you want to find out the atom, you just have to simply multiply 2 with the molecule, because in one molecule we are having 2 atoms. So in how much molecules we are having 2 times of atom, that means 2 into 1.5 into 10 raised to the power 20. 3.42 gram of sugar. Very good beta. Sucrose, C12H22O11. So if you want to find out the atoms, how to do so? Atoms, whatever the number of molecules come, you have to multiply by, see how many atoms are there in a molecule? 22. Means you can add these number all up, right beta? 22, 33 means 12 plus 22 plus 11, you have to add them all up. That is the total number you are getting over here, right beta? So it will come out to be 45. 45 will be the total number of atom in one molecule of sucrose, right beta? So that is how you have to just multiply the 45 term with the number of molecule. Now how to get the number of molecule? We are having the mass given to you. So given mass by molar mass 342, sorry, given mass by molar mass into Na will be the number of molecules, and if you multiply the molecules with the atomicity, that means number of atoms, you will get the total number of atoms. Okay. This PDF will be available there. Yes, you can get the PDF there in the platform only. Check the description and you will get the PDF there in the platform, in the application. Okay, beta. 52 gram of helium. Beta, helium. Again, atoms will be equal to the number of moles into Na. Number of moles into Na. And in place of number of mole, you can use the formula of mass. 52 upon mass of helium is 4. Helium mass is 4 into Na. This is the overall number of atoms you will get from this. Now 52 AMU, very important, beta, 52 AMU. In that formula, you use grams, right? So first of all, you have to convert this AMU to grams. So atom number will come out to be 52. That is in AMU. You have to convert it in grams. 1.67 in 10 raised to the power minus 24 grams. Remember, we do talk about the gram conversion from AMU by this divided by the molar mass of helium, that is 4 into Na, and thereby you can use the same relation that we are using with the other question as well. These are very, very important thing, and I want each and every one of you to listen this concept carefully. Keep on practicing the concept. Only after that you will be able to solve these type of question. Otherwise, it will be very difficult for you to do so. Now, these are the homework question, beta. These are the homework question. Okay, you all have to solve these question. They are asking you number of molecules now. Number of molecules, that means they are for 0.2 mole of hydrogen. So this is hydrogen is molecule only. Here they are giving you the atom itself. So atom is given to you. That means if you do find the particle formula is atom only, because this is atom given to you. Remember the particle formula that I told you there. Particle is equals to N into Na. And in place of particle, what I told you, whatever they are giving you there in the question. Here they are giving you the atoms, isn't it? So particle, in place of particle, atom will come. Number of moles into Na. But they are asking you about molecule. So for molecule, what you have to do? Whatever atoms you are getting, you can see that in hydrogen atom, how much molecule it will form? Atom will form H2 molecule. 2 atom will form 1 H2 molecule, right? 2 atom will form 1 H2 molecule. 2 atom will form 1 H2 molecule. 2 hydrogen atom will form 1 H2 molecule. So for finding out the molecule, whatever atom you are getting, you just have to divide it by 2. Okay, beta. Whatever atom you are getting, how the atom are calculated? 0.2 into Na. So you just have to divide it by 2. So as to get the molecule, how many H2 molecule are there? So 0.2 by 2 Na. That means 0.1 is the number that you will get. Okay. So this is how you have to solve. Gram atom means they are giving you mole hydrogen. Again, you have to do the same thing because it is atom and you have to find the molecule. So yeah, they are giving you the same question, but in place of mole, they are giving you what? Mole atom. Okay, beta. Beta, this is English channel. So Hindi will not be there in this channel. This is for English only. Okay, beta. Then moving on to gram molecule of oxygen means mole given to you. 0.5 mole oxygen. So you can simply multiply it by Na and the answer will be there. 7 gram of nitrogen. Nitrogen is N2, beta. So how to find the molecule over here? Molecule can be calculated by N into Na, and in place of N, since mass is given to you, so it will be 7 by 28 into Na. Given mass by molar mass. Given mass is 7 and molar mass of N2 will be 28 into Na, and that is how you can easily find it all out. That is simple. Okay, moving on to next topic then. Beta, these are different type of question. You all can solve it all out. Now, one more highlighted one. Rest of the question you can solve this all. Okay. But there is someone is saying you are my dopamine without dopa. Dopamine. Dopamine. Dopamine without dopa. अच्छा ये गया. Okay. Mine. Beta, just be stay focused on the topic that we are discussing. Your dopamine, I don't know about the dopamine that you have, but you have to answer the questions so as to get a decent college in your JEE, right? Okay. Somebody is saying Japan without P. What is this? Japan. Okay. I'm getting you, beta. I'm getting you. Okay, beta. So 18 ml of water. See, right now you don't need to use that volume wala formula. Why is it so? Because they are not mentioning the STP condition. You might be wrong in this question because 18 ml of water without STP. That means you have to use that number of moles if you are using the formula of number of moles. Then given volume by 22.4, this formula is used for STP condition. So you don't have to use this formula. You'll get the wrong answer. Okay. Here you have to see that water is given to you. For water, the density is 1 gram per ml. So if 18 ml is the volume given to you, so the mass will come out to be, because density is equals to what? Mass by volume. And if this is 1, so mass is equals to beta volume only. So 18 ml will be equal to 18 gram only. So this is the mass that is there. 18 gram is the mass over here. So here you just have to find out the atoms. They are asking you the atoms only or moles formula. Number of moles can be calculated given mass, that is 18. Molar mass of H2O is 18, that is 1 mole. So by this thing, you have to be clear that don't use that formula of volume in this case until and unless STP is not mentioned. If STP is mentioned, then you can use the formula. Otherwise, you can not use that formula. Okay, beta? You can do the rest of the question and do let me know in the comment section by marking the timestamp that at this time Gigi ma'am asked us the question and we have to mention the answers there in the comment section after the live end, and I will actually read your comment. I will see that how many of you who are attending the question are giving the correct answer. Okay. Okay, beta. Is it clear to you all? Okay, everyone. Is it clear to you all? Calculate the volume. Same these type of question. We have practiced many more questions. Just try them all. This is again a very important question. You have to arrange the following in increasing order of their masses in grams. So first of all, you all have to find out the masses and accordingly have to arrange them in order of their mass. I will see that how many of you are giving the correct answer and how many of you are not. Okay? Okay, beta. Okay. What is the mass of carbon present in 0.75 mole of potassium ferrocyanide? These type of question. Potassium ferrocyanide. For now, if you don't know the formula, you won't be able to solve this all out. That is why I'm telling you again and again that do maximum to maximum questions. Then only you will be able to solve these type of questions, beta. Okay. Potassium ferrocyanide is like this. And you have to tell that what is the mass of carbon present in this much amount of this much mole of this. You have to tell the carbon how much mass. Okay, in these type of question, firstly find out the moles. Okay, so here we can say that in this molecule you can say that one molecule of potassium ferricyanide contain how many carbon? Beta 6 carbon, right? 6 carbon atom, right? If one mole is there, potassium ferricyanide, okay, it contains 6 mole of carbon atom. One molecule contains 6 atom, one mole will contain 6 mole of atom, right? Right? Okay. Okay. Okay, beta. What is your name? Beta, myself, Gigi ma'am, Gunjan Goyal, and from today itself I'm teaching you chemistry. Okay. Yes. Okay. So 1 mole potassium ferricyanide contains 6 mole carbon. So we are having 0.75 mole. 0.75 mole potassium ferricyanide contain 6 time of 0.75 mole carbon atom. So you are getting now the mole of carbon. And if you know the mole, you can find out the mass by multiplying it with molar mass, right beta? So just have to multiply the mole, that is 6 into 0.75. Multiplying by molar mass. Beta, what is the molar mass of carbon? That is 12. There you will get it out in the grams unit. As simple. Okay beta. So this is how you have to solve these type of questions. Moving on to next question. Calculate the mass of CO2 which contain the same number of molecules as in 80 gram of oxygen. Beta, 80 gram of oxygen. Oxygen given to you is 80 gram. 80 gram. So molecules are same. Calculate the mass of CO2. We have to calculate the mass of CO2 whose molecules are same only beta. So molecule formula you can equate in terms of mass. What is the formula of molecule? Given mass. Okay. So molecule you have to equate out. For the molecule, you can use the formula of mass-molecule relation. Remember the molecule relation with the mass. How? Number of moles into Na. Number of moles into Na. And for the number of moles, you can write given mass by molar mass into Na. Given mass by molar mass into Na. For these two things, Na is the common thing that can be cancelled up. Mass you have to calculate for CO2. Molar mass of CO2 is familiar to you, that is 44. Mass of oxygen is given to you. Calculate the mass of which contains same number of as in 80 gram of oxygen. And molar mass of oxygen O2 is 32. So by solving the question, you will get the value of X in grams only. This is how you have to solve these type of questions. Okay, beta? Okay. Okay. Moving on to more type of question like this. Calculate the mass of which contain the same number of molecule. Beta, this is your homework question again. On the same pattern that I told you as of now, you just have to put the values on a same on same formula. मैम एक का molecular mass कैसे निकालें? Okay. Whose molecular mass you want me to find out? Molar mass for whom? Okay, so this is the homework question. You just have to simply put the values just like the previous question I did. Same question goes with how many moles of magnesium phosphate contain 0.5 mole oxygen atom. Magnesium phosphate, Mg3PO4 twice. This is the formula of magnesium phosphate. Now, again you have to do that unitary method. Since we know that in one molecule of magnesium phosphate, how many oxygen atom are there? 4 2s are 8 oxygen atom. In 1 mole magnesium phosphate, 8 mole. So mole relation, oxygen atom. And if I want to find out the what? How many moles of magnesium? So X 0.25 mole oxygen is given to you. So you can just simply find out the value of X by this formula. So X will come out to be how much beta? I'll repeat it once again that these type of questions are very important for you all. Just have to use the method that this is the formula and we know that in one molecule 8 oxygen atom are there. So mean in 1 mole 8 mole oxygen atom are there. In X mole 0.025 given to you oxygen atom are there. Just equate it like this and simply you can find out the value of X. So X will come out to be how much? This will come out to be 1 into 0.25 upon 8. This will be the mole of magnesium phosphate. As simple. Very simple question, simplest of all. I'm telling you all that these type of question gonna boost your score and they are very easy to find out. Air contain 21% oxygen by volume. How many atoms of oxygen are present in 1 liter of air at STP? Now try to solve this question as well. Let me see that how many of you are attempting the question and are capable of solving it. See, air contain 21% oxygen. That means 100 ml air contain 21 ml oxygen, and they are asking you about 100 ml air will contain 21 ml oxygen, or you can say in liters as well, that 100 liter of air will contain 21 liter oxygen. 1 liter air will contain 21 by 100 liter oxygen. So this is the volume you are getting. From volume, STP condition are given to you, beta. Right? So from this, you can find the molecules first of all. Molecule will be mole into Na. Right, beta? And this is not the mole that we are familiar with. We know the volume part. So we can use the formula of volume in place of mole. That is given volume at STP. That is 21 by 100. Right, beta? Liter into Na by 22.4 by 22.4. In place of mole, I have used the formula of given volume by 22.4 liter per mole. So you can use the formula to find out the molecule, and in the question they are asking about the atom. So how the atom are obtained? By multiplying the molecule with 2 and you are getting the answer of atom. So this is the molecule. Just have to multiply it by 2 and you will get the final answer of number of atoms. All right, beta. This is how you have to solve the question over here. Okay. So these type of questions are very common. From 200 milligram of CO2, 10 raised to the power 21 molecules are removed. You have to calculate remaining molecules. You have to calculate remaining moles. So if you want to find out the molecules, you have to convert them both in molecule pattern. So remaining molecule, remaining molecule, remaining molecule. If you want to find, you have to take the total initial molecules. Since mass is given to you, you have to convert mass to molecule. So how to convert it all? 200, first of all, milligram. Beta, milligram is minus 3 grams divided by molar mass. It is divided by molar mass. It is mole, right? You can multiply mole with Na and you will get the molecules. This is molecules. This is molecules. This is molecules. So 200 milligram CO2 means this much molecules. We are removing 10 raised to the power 21 molecules. So you can easily subtract them out. You can get the remaining molecule. You all have to solve the question, beta. Right? Right? You just have to solve the question. How? First of all, convert this term, this mass term into molecules and subtract the molecules that are given over here accordingly. And if you want the remaining molecules, remaining moles, so after you find this value, you have to multiply this. You have to number of molecules that you obtain over here divide by Na. You can easily find out the mole, remaining mole. Okay, so first of all, find the remaining mole, and after that, remaining mole can be deduced, meaning mole can be reduced by dividing it by Na, and you will be able to find out the remaining mole from the remaining molecules. Okay, so this is how you have to solve these type of questions. Okay, so I will give you some homework questions. Accordingly, these are homework questions. On that timestamp, particular timestamp, just solve them all out and do let me know in the chat section only after the session. Okay, I will tell you this question. Calculate the number of electron, proton and neutron in 1.6 gram of methane. This is very important question. This question, I'll explain you the question. Okay, 1.6 gram of methane, CH4. Beta, first of all, whenever they are asking you about the number. Okay, they are asking you about the number. Find out the molecules first. Find out the molecules first. Okay, find out the molecule first. Molecules are mole into Na. Mole into Na. Now molecules of CH4 are deduced. Mole is given to you? No ma'am. Mass is given to us. So given mass by molar mass is the replacement of this mole formula into Na. Given mass given to you is 1.6. Molar mass of methane is 16 only. Find it out. Carbon mass is 12 plus 4 for hydrogen into Na. So it will come out to be 0.1 Na. These are the number of CH4 molecules of it. Now they are asking you about electron, proton and neutrons. So you just have to find out in one CH4 you are having one carbon. Number of electrons in carbon are how many? Electrons in carbon are 6. Okay. And then protons in carbon are how many? Protons are also 6. Then neutrons. Neutrons in carbon are carbon 12 is only taken. So neutrons are also 6. 12 minus 6 is 6. Mass number minus atomic number. So proton, electron, proton and neutron of carbon are there. Okay, this is for carbon. Similarly, you can go for hydrogen. CH4 is there, right? So electron of hydrogen are, we are having 4 hydrogen. So we are having 1 into 4 because hydrogen contains 1 electron. So 4 into 1. We are getting it out to be 4 overall electron. Protons are how many for hydrogen? Atomic number is 1. So proton are also 4. Neutrons are not there in hydrogen. If we take hydrogen, 1, 1. 1 minus 1 is 0. For all the students who just started our class from beginning itself, they are capable of doing this thing that I'm telling to you, right? So total electron comes out to be 6 plus 4, that is 10. 6 plus 4, that is 10. And 6 plus 0, this is 0 beta. So overall neutron are 6, right? So these are electron, proton and neutron count. I'm just adding these things, right beta? So if I know the total number of molecules, I can easily find the electrons. Electrons are how much? In one molecule, 10 electrons are there. In 0.1 Na molecule, we are having 10 into 0.1. Okay. Similarly for proton, 10 into 0.1 Na. And similarly for neutron, we are having how many neutron? In one molecule, 6 neutron. And in 0.1 Na, 6 into 0.1 Na. So this is how you can solve these type of questions. They are very special questions. Whenever they are asking you to find out the electrons, ma'am, are you going to teach all the chapters of chemistry? Yes, beta. If you are asking about the chapters, if you want me to cover the chapter, do let me know in the comment section. I will definitely gonna teach you the chapter that you want us to cover. We will all bring the chapter to you. Okay. Okay, beta. Moving on to next concept then. These all are the questions that are very important for you all guys. Just keep on solving them all and you will be able to do the major portion of the mole concept 4. Okay, and now the next topic after this, beta, these are the homework question. Solve these as well. These are the homework question. Solve these as well. Like I am giving you the questions as well, that how to solve which type of question with what pace, with what methodology. All right, just after the session, revise it and try to solve them all out. Okay, beta. Moving on to next thing now. That is NTP, STP, SATP condition. Remember, whenever they give you NTP, normal temperature pressure, these are the temperature pressure things. Temperature for NTP is 20, pressure for NTP is 1 atm. For STP, standard temperature pressure. Temperature is 0 degree, pressure is 1 bar. Then is SATP, standard ambient temperature pressure. Temperature is 25 degrees Celsius and pressure is 1 bar. Then we are having different relations. These will help you out in solving the questions. If pressure 1 atm, we are linking it with 1 bar. This is 1.01325 bar relation with the atmosphere. We can say that 1 atm is rough average equal to 1 bar only because the value is close enough, right beta? Okay beta. 1 atm relation with mm of Hg. These all are pressure units beta. 1 atm is 760 mm of Hg, that is equal to 760 torr. And if we do discuss about the liter atm relation with joule, see, these are the units of work that we use. Liter atm is related by joule with 101.3 and 1 calorie is equals to 4.1. We can say almost equal to 4.2. Rough average, we can take it to be 4 as well sometime there in the question. So this much joule, like this. 1 calorie is equals to 4.2 joule. These all are the relation that we use there in the question. How we are using it all? By solving the ideal gas equation. Beta, PV is equals to nRT is the ideal gas equation. Okay, by putting the values of, let us say, a particular, if I want to find out the P, over here is pressure. Okay, usually we take it in atm. V is the volume, usually we take it in liter. N is the moles of gas, number of moles that we find out with different relation. R is the gas constant, right? And T is the temperature. T is the temperature that we use in Kelvin. Mole we use in mole term. Then these are the relations. If we do put the values under standard condition, okay beta, we can get the R value. R value are used differently depending on the units that we use. Okay, R can be equal to 0.0821 liter atm Kelvin inverse mole inverse. Right now I told you liter atm conversion to joule, right? Remember 101.3 joule. So we can substitute the value and convert this liter atm to joule by getting the value to be 8.314. Okay, and if you want to convert joule to calories, how to convert? Right now I told you that 1 joule, 1 calorie conversion to joule, 1 calorie is equals to 4.2 joule, right? So this is how you can convert this joule to calorie. Accordingly, you will get the R value to be this one. So these are the 3 R values. Depending on the type of question, depending on the type of units, we can easily frame up. Let us try this with an example. Calculate the volume occupied by 10 raised to the power 21 molecule of gas at 300 Kelvin and 700 mm Hg pressure. Okay beta, let us solve this question. Since we are providing with the rest of the thing of this ideal gas equation, they are asking us what? They are asking us volume. Okay, number of moles is equal to given volume, that is 10 raised to the power 21 divided by Avogadro number 6.022 into 10 raised to the power 23. R is the gas constant, and which gas constant to be taken? You can use 0.0821 liter atm mole inverse Kelvin inverse. Why ma'am? Because right now pressure unit that you gonna use over here is atm, but ma'am 700 mm Hg given to us. Then what we will do? Beta, you can convert 700 mm Hg to atm by dividing it 760. Right now I told you the relation. See over here, 1 atm is equals to 760 mm of Hg. Accordingly, you can divide it by 760 and you will get it in atm unit. Okay, volume you will get in liter, number of moles in mole, and temperature is given to you, that is 300 Kelvin. So accordingly, you can substitute the value and you can easily find out volume over here. So volume will come out to be, just solve the values and you will be able to find out the, by P, you will be able to find out the volume by just substituting the values. Okay beta? Okay, yes, clear? So just put the value and you will be able to solve the question by your own. Then moving on to vapor density questions. Beta, what is vapor density? Just simply revise it by the concept that we are relating the mass of a particular volume of gas with hydrogen. Okay, what is vapor density of gas? Vapor density is mass of V volume of gas with respect to mass of same volume of hydrogen. And if I do take the mass of V volume to be mass of one molecule of gas, so So I will relate it with the mass of one molecule of hydrogen gas. And you know the mass of one molecule of hydrogen, what it is? It is 2. So vapor density will be equal to mass of one molecule, that is the molar mass of gas. Molar mass of gas divided by mass of one molecule of H2. One molecule of H2 comprises mass to be what? It is 2 only. So beta, molar mass equal to, we can say, molar mass of gas is equals to 2 into vapor density. 2 into vapor density. This is very important question that is used many times there in your examples questions. Okay, so you have to use this formula in the question depending on the type of question that they ask. For example, this is the question, beta. This is the question. This is the question. For example, you have to solve this question. Vapor density of a gas is 22. Beta, any gas, we don't know about it, the vapor density is given to you. That means you can find out the molar mass. Molar mass, right now I told you that 2 into vapor density is the molar mass. So 2 into vapor density is 22, that is 44 will be the molar mass. The gas can be, what is the possibility of it? You can easily find out the molar mass. CO2 molar mass is 44, right? And N2O, 2 into nitrogen is 14, oxygen is 16. It will also come out to be 44 only. So both the gases, molar mass coming out to be 44 only. That means there is a possibility of any of the gas. So the correct answer over here is both. Okay, so this can be any of the gas which comprises the desired question. Okay, beta. Okay. Then we will cover after this different laws, and these laws are very basic laws. First of all, we'll go with the first law, that is law of conservation of mass. You all know this law, that mass can neither be created nor be destroyed in any chemical reaction. That means the mass of reactant is equals to the mass of product. Mass of reactant should always be equal to the mass of product. Okay, we are done with our 100 likes today. Okay, very nice. Okay, celebration. Okay, so yes, the mass of reactant will always be equal to mass of product. So this is the basic law that states that indestructibility of matter, that matter cannot be destructed. It is just converted from one form to another form. That is it. We can have some different type of experiments as well. Let us suppose this is NaCl and AgNO3. Before the reaction they were separated. We just shake them both. We are getting the new product. These are reactant, these are product. The weight initially and final weight will always be the same. That is it. Okay, yes everyone. This is the law. Very simple law, very basic law. We will not go in much more detail because this is very simple. Moving on to next law, that is law of constant composition or definite proportion. What this law state is that we are having the compound. If the compound contain the elements, they always be in same constant ratio. That means, for say, if we are having, let us say copper carbonate, let us say CuCO3. This is the compound. CuCO3. This is the compound. Okay. So beta, CuCO3. For say we are having a natural source of copper carbonate from any XYZ source, and we created this cupric carbonate. Okay, we created, and somehow we have two samples. One is created by us, another sample was abstracted there from the nature, and we are just mentioning, or we can say we are just calculating out the percentages of each element there in the compound. Okay, so first element, the naturally occurring cupric carbonate compound contains copper in this percentage, carbon in this percentage, and oxygen in this percentage. Then this cupric carbonate prepared in laboratory by us, then we find out the percentage, it comes out to be the same. This is the law that irrespective of any source, it will always comes out to be the same. The ratio of their masses will always comes out to be the same. Let us say we can take an example of water. Water from my home, water from your home, water from lakes, water from ocean, water from vapors. Any water will always contain the ratio of hydrogen and oxygen to be the same. Okay? Okay, beta. Okay. So this is all about, this is the example like CO2 produced from different sources. Another example, from burning of coal, heating limestone, CaCO3 reaction with HCl from NaHCO3. So the CO2 produced from all the sources contain the carbon and oxygen in which ratio? CO2. Carbon mass is 12, oxygen mass is 16 into 2 because 2 oxygens are there. So 12:32. You will get it out to be 3:8 only. So irrespective of the source of CO2 produced, we always have the carbon oxygen in same ratio only, beta. This is the law. We'll try our level best to cover the topics, beta. Rest we'll see, because my main task is to clear the concept. That is all from my end. Law of multiple proportion. Multiple proportion means that when two elements, first of all, Dalton proposed this law. When the two elements are combining to form more than two compounds, let us say hydrogen, oxygen combining to form two compounds, H2O and H2O2. We can say the ratio of hydrogen, oxygen over here is 2 into 1 ratio oxygen 16, 2:16, 1:8, right beta? In H2O2, we are having the ratio comes out to be 1:16, right beta? So when two elements combine to form more than two compounds, the mass of the element that combine with the fixed mass of other element. Fixed mass, let us suppose 1 is fixed over here of hydrogen. So mass of one element, that is oxygen, that is combining with the fixed mass of other element, these two ratios of oxygen, 8:16, 1:2. So this ratio is coming out in whole number. This ratio is coming out in whole number. So this is the law. When the two elements combine to form more than one compound, then the mass of one of the element which combine with the fixed mass of other element is in the simple whole number ratio. When the mass of other element is fixed, at that time the ratio of the two elements coming out to be in the simple whole number ratio. That is it. Okay, beta. Okay, is it clear? Suppose this is the example that I told you as of now. Moving on to reciprocal proportion, beta. What is the meaning of this law? This is again another law by Richter. Okay, Richter was the scientist who stated this law. What he stated in his experiment, in his law, is that we are having a, we can say, triangle. Okay, this is another angle where we can say that hydrogen, sulfur and oxygen, three elements are combining differently with each other, right? So here we are saying that hydrogen, sulfur, hydrogen, oxygen, H2O and H2S, right beta? Hydrogen and oxygen, hydrogen and sulfur, 2 ratio sulfur is 32, right? And 1:16 is the ratio that we are getting from this. Again over here H2O, 2 ratio oxygen is 16, 1:8. Simplest ratio of mass I am rating over here in H2S and in H2O. That means sulfur and oxygen, ratio of sulfur and oxygen from these two is coming out to be 16:8. That means 2:1, right beta? And when the sulfur oxygen combining with themselves, it is creating SO2. And sulfur mass is how much? 32. Oxygen mass is 2 into 16, that is also 32. 1:1. So this ratio of sulfur oxygen, that is obtained from the different compound. And when they both react there with each other, this ratio, if we compare these two ratio, we are getting it out to be either same or the ratio is in whole multiple. This is the law of reciprocal proportion. Okay? Yes, beta. This is the law. We'll cover with the stoichiometry after this only, beta. Okay, beta. This is the law. This is the law that is very, very important for you all. This is the law that is very, very important for you all. So this is the reciprocal proportion, the ratio that you are getting when they separately combine with another element and when they both combine with each other, either it is same or it is the whole number multiple of each other. Okay, beta. So this is about the law. Then the Gay-Lussac law, combining volume. We can say the gases react together to produce a chemical reaction. They always combine in a whole number ratio, like 1 volume of hydrogen and 1 volume of chlorine combine to form 2 volume of HCl. So 1:2 is the whole number ratio that you are getting over here. So just simple. Similarly, H2 2 volume of H2, 1 volume of O2 together combine to form 2 volume of H2O water vapors. So 2, 1, 2. It is also the whole number ratio. Okay, beta. That is the loss. Now we will shift to the percentage composition portion. What is percentage composition? We are having, let us suppose, any compound. Let us suppose we are having H2SO4. Okay, percentage composition means we are finding out the percentage of a particular element. Let us say we are finding out the percentage of hydrogen in this. So hydrogen are 2 in number. So 2 into mass of hydrogen is 1 divided by total. Total is the mass of H2SO4, that is 98 into 100. So this is how the percentage of the element is found out. So you can write the percentage of element. How to deduce that? The mass of element upon total mass. Yeah, or you can say the molar mass of compound. Molar mass into 100 into 100. This is how you can find out the percentage of element. Or you can say the mass of element overall, total mass, you can say. Okay, how the total mass is deduced? The mass of element into the number of element. You can also change the formula that we are having the number of element into mass of element upon molar mass. Just right now I did it for hydrogen, that two number of hydrogen number are 2. 2 into mass of hydrogen, that is 1, divided by total mass, that is 98 into 100. Okay, if I do write it over here, the percentage of element, if I take intentionally minimum one element, at least a single element is there, for example. So if I do write over here number to be 1, mass of element, whatever the element is, so by putting it as 1, I will get minimum molar mass. Beta, this formula is very important and this was asked many times there in your JEE examination. Minimum molar mass. Minimum molar mass. So this is the formula that we're gonna use in different type of question. I will tell you that question that we will cover after this. So percentage of sulfur, if I do want to find out, sulfur is 1 only. Mass of sulfur is 32. Mass of sulfur is 32 by total mass, that is 98 into 100. Similarly, if I do want to find out the percentage of oxygen, so 4 oxygen are there. Mass of oxygen is 16 divided by total, that is 98 into 100. This is how you can individually find out the percentage of any element that is present there in your compound. Is it clear to you all, beta? This is how you have to find it all. Okay. Moving on to the question portion. Percentage of element in urea. This is your homework portion. Whenever I say that you have to solve the question for your homework, okay, so whenever I ask you for any question, that in your homework, you all have to solve it out. After the session ends, you have to answer me the question there in the comment section by putting that timestamp, that ma'am, over this time you ask us a question, we solved it, and this is the answer that we are getting. I'll personally read the message of it. Okay. 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 So this is the question. Insulin contain 3.4% of sulfur. Calculate minimum molar mass. See, this is the question that I am telling to you. Minimum. So sulfur percentage is given to you, that is 3.4%. Okay. Minimum molar mass. So sulfur mass is 32 and minimum molar mass is X. So by just putting the value over here, you can find out 32 by 3.4 into 100 to be the minimum molar mass. These are very simple question and many students find the difficulty in solving them. Ma'am, what is the minimum molar mass? We don't know. Just have to simplify the formula depending on your question. What are the things they are asking you and what are the things they are giving you. Okay, beta. Similarly, compound contain 20% nitrogen by mass. That means the percentage of nitrogen given to you. If one molecule of this compound contain 3 nitrogen atom, calculate the possible molecular mass. Again the same formula. Percentage of nitrogen given to you, 20%. How many nitrogen atom? 3 nitrogen atoms. So mass of nitrogen is 14. Molecular mass, they are asking us. So we over here will write the molecular mass. So into 100. So we can easily find it out by putting the values of rest of the member. Is it clear to you all? This is very simple. I'm telling you all guys. Just simplify the question by using this formula. And this was the question that was asked there in your previous year. Like this was your PYQ of JEE only, JEE Main only. Hemoglobin contains 0.25% of iron. 0.25% of iron. That means percentage given to you. Molar mass is given to you of hemoglobin. How many iron atoms? Now you have to find out the iron atom. So percentage of iron is 0.25. We don't know about the atoms. Just write it down as X. Mass of iron is 56. And total mass is the mass of hemoglobin, that is 89600 into 100. By putting the values, finding out X, you can answer. You can simplify the question and get the answer of the number of atom present in the molecule of hemoglobin. Is it clear to you all, beta? Just have to solve the X by just putting the value. Okay, beta, this is very simple. This formula is very simple. You can easily solve any of the question by using this formula. Okay, beta. Moving on to the next concept, that is molecular mass, molecular and empirical formula. What is it? Molecular formula is simply the formula of a molecule. For example, if I do ask you about the molecular formula of glucose, so it comes out to be C6H12O6. Right, beta? This is the molecular formula. That means the actual number of atoms present in a molecule. But what is empirical formula? What is empirical formula? So, beta, empirical formula is the simplest formula. It is the simplest formula. Okay, we will take 15 more minutes to cover this session, to cover the another portion as well. So, I will take your 15 more minutes. Okay. Yes, I'll drink some water. Thank you so much for asking. Yes, for the same. Okay. Yes, beta. Empirical formula is the simplest ratio. 6, 12, 6. Can it be divisible by a number to get a simple ratio? Yes, ma'am. We can divide it by 6. We can get it to be CH2O. This is the simplest formula that we will get. This is the empirical formula. It is the simplest ratio of the elements that are present there in a molecule. That simple. We will do certain questions to solve it all out. Okay. Does PYQs are enough for mains? Better for PYQs, you have to practice certain questions. Okay. So not only PYQs are sufficient, you have to maximize your practice by doing multiple questions as well. Okay. Fine. Which of the following pair contain the same percentage of oxygen? Which of the following pairs contain the same percentage of oxygen? Just have to find out the minimum formula, that is empirical formula. C2H coming out to be 4O2. So it will be minimum like this. CH2O, you can divide them all with 2. Here as well, 1 to 1, that means CH2O. So they both contain the oxygen in the same percentage. Which of the following pair contain the same percentage? These two contain the same percentage of oxygen. We can shift to another question as another option as well. CH2O. And this right now I told you about the formula of this CH3COOH, that is minimum formula comes out to be CH2O. Here CH2O, C6H12O6, CH2O. This is also getting the same ratio only. So all of these will be the correct answer. Okay, beta? Yes, beta. Is it clear? Is it clear? Is it clear to you all? Okay. Okay, so let us proceed with another question. Atoms of A combine with this much atoms of B to form a compound. Calculate the empirical formula. Beta, whenever numbers are given to you, just have to take the ratio of them, because number of atoms means the moles are also, we can relate them as mole. See how 6 into 10 raised to the power 20 atoms given to you, and 15 in 10 raised to the 20 atoms of B given to you. If you want to convert to moles, how you will convert the atoms to mole? By multiplying it with Na. By multiplying it with Na. So Na is the common term, will be cancelled out. So that is why whenever number of atoms, number of molecules given to you, you can simply take the ratio as it is. No need of conversion at all. Okay. But if mass is given to you, you have to take them in terms of moles. Okay. I'll tell you how. So over here, just have to simply take it like 20 cancelled up with each other, and 3 2s are 3, 5s are 2 ratio 5 will be the empirical formula. A2, B5, this is the empirical formula of the question given to you. See, there in this question, what I was telling you, here you will get the concept more clearly. Silicon, mass number given to you, compound with chlorine. So, beta, we are having silicon, we are having chlorine, in which 5.6 gram of silicon is combined with. So, we are having 5.6 gram silicon that is combining there with 21.3 gram of chlorine. Okay. Empirical formula you need to calculate out. So silicon and chlorine given to you. Mass number of silicon is 28 and mass number of chlorine is 35.5. Right, beta? You have to solve them all out. This is the mole. This is the mole. Now you are getting gram per mole, gram per mole. So this is the ratio of mole of them. This is the ratio of mole of them. Now you have to convert it in simple form. In simple form. In simple form. In simple form. Now, how you will be able to convert to simple form? The least value among the two, you have to divide them both with this. And accordingly, a whole number is generated. Is it clear to you all? This is the ratio, but this is complex ratio. You have to solve them both. The one that you are getting in least number, you have to divide that value with the 2. And accordingly, multiply with a suitable term so as to get a whole number. And that will be the empirical formula you will get over there. Is it clear to you all, beta? Is it clear to you all? Will you all be able to do this question by your own? Will you all be able to do this question by your own? This is the empirical formula thing, empirical formula part. Accordingly, you can solve the question. Okay, is it clear? Any doubt, any query so far? I think that the concept is clear to you all, guys. Correct? Okay, fine. This is how you can find the empirical formula. Again, 60 gram of compound analysis produce 24 gram carbon, 24 gram, hydrogen 4 gram, oxygen 32 gram. Grams is given to you. You have to convert them all by moles by dividing it with the atomic, the molar mass, that is carbon 12, hydrogen 1, oxygen is 16. Ratio of all these will be the simplest ratio, that is 2 ratio 4 ratio 2, 1 ratio 2 ratio 1. CH2O will be the empirical formula of this structure. Is it clear to you all, beta? Yes? Yes, beta. Okay, so this is the story about the empirical formula thing. Okay, now we will shift to the main topic, that is stoichiometry. That is stoichiometry. Now, what is the meaning of stoichiometry? I'll take 10 more minutes. At sharp 9:15, we will end with the we'll end our class, and so far we will discuss about the main topic, that is stoichiometry. But what is stoichiometry? Stoichio means, we can say that what is the relation, how much quantity of a particular substance react with how much quantity of another substance to produce how much quantity of product. Okay, we are relating the things now. Relation is in the manner that we can say that N2 plus 3H2 give rise to 2NH3. Let us take an example of this equation. I am having one molecule N2 react with 3 molecule H2 and producing 2 molecule of NH3. I can also write it as 1 mole of N2, 3 mole of H2, 2 mole of NH3 are produced. Okay, beta. I can also write it in terms of volume, that 1 volume of N2 react with 3 volume of H2 to produce 2 volume of NH3. That means I can write it as 1 ml of N2 react with 3 ml of H2 to produce 2 ml of S, like this. 1 ml react with 3 ml to produce 2 ml, like this as well. But I cannot relate it like 1 gram. No. 1 kilogram. No. Mass can never ever be the same relation in terms of the reaction that I stated over there. Like it will not be like 1 kg, 3 kg, 2 kg. This is wrong assumption. We cannot take it like that. We have to convert the mole to mass. Like 1 mole means, N2 1 mole means 2 nitrogen. That means 28 grams. For hydrogen, we are having 3 mole. So 3 into H2. H2 means 2. That means 6 gram. 2 NH3. So 2 into NH3. 17. Okay. So that is 34 gram. NH3. 1 nitrogen is 14 and 4 plus 3 for hydrogen. That is total 17. So we are getting this thing. Okay, beta. So I am telling you that this is how we can relate the things. This is the stoichiometry. If this much is reacting with this much, so how much amount is produced, that is stoichiometry. For example, if we do have any other example, let me take an example to help you all out. Let us say this is the example. Calculate the volume of CO2 obtained by decomposition of 5 gram CaCO3. So we are having CaCO3 that is decomposed. Decomposed means if we are heating it up, we are getting calcium oxide and CO2. This is our equation. They are asking us what is the volume. What is the volume of CO2? They are asking us the volume of CO2. Obtained by decomposition of what? 5 gram of CaCO3. Means 5 gram CaCO3 when decomposed, then how much CO2 is produced in volume, in liter. Okay. So first of all, convert this 5 gram term into what? In mole. We can easily relate the mole terms. Right now, you can link it with the mole. That 1 mole, is the reaction balanced? Yes, ma'am, the reaction is balanced. For solving the stoichiometry type of things, first of all, there is the certain step you have to follow. You have to firstly balance the reaction, write down the reaction in a correct way, balance it up, then relate it. Okay, this is the sequence you always have to follow. That is, firstly, you have to write down the equation. Then you have to balance the equation. Then you have to link the relation. I've written the equation, I've balanced the equation. Now I am linking it up. CaCO3 is given to you, CO2 they are asking you. That means 1 mole of CaCO3 produces 1 mole CO2. Right, beta? 5 gram given to you. Convert it in mole. 5 gram given mass 5. Molar mass of CaCO3 is 100. Beta, this is the gram per mole. So by this given mass by molar mass, you are getting the mole of CaCO3. So this mole of CaCO3 will produce how much? This much mole only. 1 mole is producing 1 mole. That means 5 by 100 will produce 5 by 100 mole of CO2. Now you got the mole and you can easily convert mole to volume. How, beta? You can easily multiply the mole with 22.4 at STP given to you and you thereby will get the volume answer. So volume of CO2 will come out to be how much? Volume of CO2 will come out to be how much? 5. That means number of moles into 22.4. Right, beta? So 5 by 100 is the moles. 22.4. If you do multiply, you will get the answer to be there in liter. Okay. Is it clear to you all? This is how you can solve the stoichiometric equations. Whatever thing they are asking you, whatever thing they are giving you, just relate them all in the mole terms. Accordingly, convert your question in the way they are asking you all about. Last thing is the limiting reagent that we will cover over here. Limiting reagent. Now, what is the limiting reagent part? Limiting reagent is just to name you that if we are having 2A, 3B giving us 4C, right beta? Right beta? And there in the question, they are giving you both the reactants. Let me make it very clear to you. For example, you have to make tea for the guests that arrives there in your house. You have to make tea for them. Okay. Now to create a tea, you need milk, you need sugar, right beta? If you are having any one thing in limit amount, let us say milk you have in limit amount, will you be able to prepare the tea in that much quantity? For example, you have to make tea for 5 cup tea. 5 cup tea. And for 5 cup tea, you need 5 cup of milk, right beta? Sugar you have in many huge quantity. So to make 5 cup of tea, you need 5 cup of milk. But if you do have 3 cup of milk, now don't do it like, yes ma'am, we can add some water in it. No, there is no option at all. You have to make it with pure milk only. So we are having, let us say 3 cup of milk. Okay, so 3 cup of milk, but sugar is in huge quantity, in number of quantity, excess quantity. So how much cup of tea will you be able to make? That is 3 only. That means that milk over here is in limit. So this is our limiting reagent that will decide how much quantity of product will be formed there in a reaction. On a similar basis, let us suppose 2A plus 3B give rise to 4C. And in the question they are giving you that we are having 3 mole of A, we are having 3 mole of A, we are having 6 mole of B, then tell that how much mole of C is produced. Both the reactants given to you beta. If only single is given, you can easily link them just like the previous method that I told you. But since over here both the reactants are given to you, you have to find out the limiting reagent. How to do so? You just have to divide the moles given to you by the coefficients. 3 by 2, 6 by 3. Okay, 3 mole given to you by 2, 6 mole given to you by 3. The value you are getting over here is 1.5 and it is 2 over here. The less value, this is the less value, means A is the limiting reagent. The lesser value of mole by coefficient term will be the limiting reagent for you. So that means 1.5 is the limiting reagent. Okay beta. Now what will be the product that will be formed? This will decide the product formed. How? You can easily do it by a trick. I'll tell you a trick for solving this question. Beta, how much remaining? You know that this is a limiting reagent. It will be completely exhausted. Just like the tea that I told you to create. You know that 3 cup of milk are there and you are utilizing them all. Then finally, no milk at all will be remaining, right? So limiting reagent will always be consumed completely. So we are having 3 mole. Just subtract 3 with 3. We are having 0 mole now remaining. 6 mole of B were there. 6 divided by this term beta. This is very important. Very simple. 6 minus this term. This term is the limit term. How much it was? 3 by 2. So it will be the remaining amount. Right beta? Is it clear to you? So 12 minus 3 will come out to be, it will be, you just have to subtract the value, that is 4.5 mole of B will be remaining. What I did is, I just find the limiting value. From that limiting value, I just subtracted the original quantity taken. Okay. I'm getting the remaining quantity of B that is remaining there in the reaction. And how much product is formed? So just 4 is the coefficient of this. Multiply this term with the limiting reagent value, that is 3 by 2. So 6 mole of C will be produced. This is how you have to answer the question. I'll repeat it once again. How did I solve the question? Just write down the limit value. How? By dividing the moles given to you by the coefficient. The one you are getting in less number is the limiting reagent. Another one is the excess reagent. How much remaining quantity is there? You just have to subtract the value, limit value from the excess reagent. Okay, you will get the remaining portion. And the limit value you have to multiply with the product formation stoichiometry. You will get the product formation, like how much mole of product is created. And from mole, whatever thing they are asking, whether volume, whether mass, whether number, you can easily find it out. And over here, remaining quantity, because limiting reagent is obviously in limit, so we will get it out to be 0 only. The remaining quantity will be 0 only. By this, you can solve n number of questions, beta. This is the question I am giving you for the homework. Just solve it all out. Do let me know in the comment section what is the answer you are getting. And that is all from my end in this lecture. The portion that are remaining, if there is anything like the purity concept, we will cover them along with the subsequent chapter of the solution only. Okay, there can be two limiting reagents, beta. If we are taking multiple reagents, multiple reactants, then they can be multiple limiting. Okay, only single limiting reagent we are taking because we are having two reactants at a time. One is in limit and another one is excess. Okay, beta, got it. Is it clear to you all? I think the concept is all done for you all, guys. That is all from my end. Any doubt, any queries, anything you want to ask me, do let me know, beta, in the comment section. Okay. That is all from my end. Okay. Do let me know in the comment section that whether the concept is done for you all. Whether you find the chapter to be easy. Whether you are capable of finding the concept to be easy. Whether you are able to solve the question all out. Whether you are getting the concept now. Okay. Yes. So for all the students who attended the session till last, salute to you all. And along with ma'am, I think that you guys together rock the session. Okay, so for all those who didn't like the session till now, just click the like button, and in the next coming class, whichever chapter you want me to cover, do mark that in the comment section of the video end. And how was the session? Do give me the feedback as well for the session. PDF will be provided that to you in the application itself. Okay, so that is all from my end. Bye bye, take care to all. Okay, bye bye, take care everyone. Bye bye everyone.